Okay. So again, where did we start with our topic? So na nga ba tayo nag-stop about, I think it's hypothesis testing, right? Okay. So just a reminder lang, going back again. So when you have your data with you and then you are ready to make conclusions or generalizations, no? Or you can start inferring about your data, there are two ways wherein you can present your inference, your conclusion, or your generalization towards your collected data. Okay. First, you can do an estimate. Okay, you can give your estimate as a description to your collected data, or you can describe it by means of doing the hypothesis testing. Okay, so both of them, you will give generalization. Okay, for example, your sample, you can say that, or you can generalize that it can truly represent the population where it came from. So this is inference or giving conclusion or generalization about that group of data. So in your estimates, you use that, okay, with a certain degree of confidence. Okay. So as your hypothesis testing, in your hypothesis testing, you also give generalization with a certain level of confidence. Okay. The difference between an estimate and hypothesis testing is that in estimate, you just give your generalization or your inference without the benefit of testing it, without the benefit of testing its significance, right? So you just have to give a certain information that is based on a certain level of confidence. But in your hypothesis testing, you also give your generalization, okay? But before you do that, you test, you have to test hypothesis, okay? You test hypothesis in order to arrive at an valid inference. Okay, so you see the difference, and also this is based on a certain level of confidence. So both of them, you generalize, you infer based on a certain confidence level, but in hypothesis testing, it should undergo statistical testing before you can arrive at a decision or a valid inference. Okay, so are we clear on that? Malinaw na tayo? Malinaw na tayo on how we're going to differentiate, or how we can give our generalization. So you can either use your estimate or hypothesis testing. So at this point in time, okay, meron ba kayong gustong tanungin before we proceed? So again, your hypothesis, it begins with your problem, and then you give temporary answers to your problem by giving your hypothesis in the form of a null and an alternate hypothesis, right? Okay, this one, you're going to use it in your decision making. But before you can use, before you can choose which one will be your valid inference, you have to test this hypothesis using statistical test. Okay, again, in order to arrive at the valid inference. And with the use of your statistical test, there are two types of statistical tests available for you to use. We have the parametric test and the non-parametric test. Your parametric test includes, example, are your z-test, your t-test, your ANOVA, your Pearson's. Okay. And your non-parametric, the most common example will be your chi-square. Okay. So I will just be mentioning, there are a lot of statistical tests available out there, but most probably we will just be playing around with these tests, which are the ones you will be encountering commonly in your practice. No? So I don't think you need the other to learn the other statistical tests, which will be beyond the need for your practice. But if you want to pursue on learning, well, by all means, please do that. But it will not be generally covered in this discussion with our course. No? So we will just be dealing with the most common statistical tests that you will encounter. Okay, so this statistical test, okay, comes with a formula, and they are presented with a formula, wherein you're going to use this formula to arrive at a certain statistic or number or a result in terms of a p-value or even a critical value or a calculated value, okay, in order for you to have a basis in making decisions. Wherein your p-value or the calculated value, which represents the sample, okay, you will use this to compare with the population p-value, or we call that critical value. Okay, so that if you have the value of both, you can compare them and come up with a certain decision. Okay, like for example, if the population value is 0.05, stated at 0.05, and your test p-value will be more than 0.05, you can come up to a certain decision on your null hypothesis, which is if your calculated value is more than the population's p-value, what would you do? What would you do with your null hypothesis? You still
Reject.
remember this one? Okay, that this is your p-value 0.05 or the population p-value. If your calculated or your test value lies more than 0.05, where will that be? Is it inside or outside the rejection area?
Inside.
So inside. So it will be located somewhere in here, huh? Closer to your population. So it signifies no difference from the population. So therefore, if it is located inside, what are you going to do with your null hypothesis?
Accept.
Accept. Okay. So if your test or sample p-value is less than 0.05, what will you do with your null hypothesis? So it will be located somewhere here, right? Outside your decision box. So what are you going to do?
Reject.
You will reject your
Reject.
hypothesis. Okay? So very clear? That's how the process of statistical testing will proceed. Okay? So in doing that, with all those things that we have mentioned, it should follow some steps, okay? So that we have the different steps in doing a hypothetical testing. I suggest you follow this step so that you will come up to a better result and you can decide properly on your conclusion or decision. Okay, so let's memorize this one. I want you to memorize this one. The first step in doing a hypothetical testing is number one, you should organize your data. Okay, organizing your data means you have to complete your descriptive stat. Okay, you have to know the different measures of central tendency, okay, the different measures of dispersion, even the distribution pattern, okay? The distribution pattern, meaning to say, is it normal distribution or abnormal distribution, okay? And then you have to identify the type of data you have, okay? What type of data do you have in hand? Okay, are there nominal? Okay, still remember this? Nominal, ordinal, ratio, interval. Okay, because this the description that you will be providing here will help you dictate what is the appropriate statistical test that you will be using. Okay, so it is very important to organize your data at the beginning so that you will understand the process flow. Okay, so after you organize your data, what's the next step? Next step will be to establish your hypothesis, your null and your alternate hypothesis. Okay, again, what is the importance of having your null and alternate hypothesis?
Validate your test.
Okay, this is where you're going to get the answer for your conclusion. Okay, this will be the basis of where you're going to get your decision. So it's either you're going to reject or you will accept your null hypothesis. And if you reject your null hypothesis, in so doing, you are accepting your alternate hypothesis. Okay. The third one is you have to state the level of significance or your confidence level. I'm saying this again and again, that every time you do something, especially on testing, or you go into play or competitions, okay, you have maybe consciously or not, you will be placing a certain level of confidence on the result or in your performance. So in your research, it is also important that you have to indicate a certain level of confidence in performing your analysis or treatment of data. Okay, this is very important that you have to do it on as early as possible because this will avoid bias later on. No? Kasi kung gagawin mo yung p-value, you will state only the p-value or your confidence level at the end. Kung kailan natignan mo na yung result ng test mo, then chances are you will be tempted to adjust your confidence level accordingly based on the test, not on the test based to your established confidence level. So magkakaroon ka na ng bias dyan. So imbes na 10% lang yung ina-accept mong kumbaga percentage of error, pwede, you will be tempted to adjust this one accordingly to your test, which is in that way you will be providing bias. Okay, so it is very important that as early as the start of your research, you should establish your confidence level. So your confidence level, you should remember that we usually base this one on a certain empiric formulas, right? You still remember this one? That the confidence level sometimes we, or most of the time rather, we base it on an empirical formula, which is the 90, 95, and the 99%. You still remember this one?
Yes, no.
Okay, so these are your level of confidence. So for every level of confidence, there will be an equivalent significance level. Okay, significance level. Again, you remember this one, the term? Confidence levels are those located at the middle, which will represent your population or your null hypothesis. Okay, and the values beyond this margin or this box will be your significance level. Correct? So that the significance level also corresponds to your p value. And we call this the alpha value. Okay? And those which are located inside the box are your beta value. So anything in this area, this line, serves as your margins. Okay? Margins of rejection, margins of error, or the limit of acceptance or rejection. so that any value of your test that lies outside this region, for example, here, this will prompt you to reject or accept your null hypothesis. If it is located outside the margin,
Reject.
reject. Okay. If it happens to fall within the region of acceptance, then you are going to accept your null hypothesis. Okay. This margin is called is labeled as your population's p-value. Remember that. P-value, or it is otherwise known as your critical value. Okay. The one that you will generate from your test is called sample p-value. Ito yung gagawin mo, yung statistical testing mo. Statistical test will provide you with the value of your sample p-value or calculated value of your sample. Okay, are we clear? Critical value is for kanina. Is it the population or the sample?
Population.
Population. Okay. Your calculated value, on the other hand,
Sample.
is the value you generate from your statistical test, and it will represent the
Sample.
sample. Okay, very good. I am tempted to explain you the critical value as early as now. So let me do that. We will talk about it later on anyway. So again, if you have your curve, this is the mean, 0, 1 standard deviation, 2 standard deviation, 3 standard deviation. 1, 2, 3, -1, -2, -3 standard deviation. Okay. We usually set our limits at 95% level of significance. So we are at 2 standard deviation. Okay, which represents your 95% confidence level. And beyond that, you have your significance level, right? This is your confidence level. Okay. Beyond that is your significance level. And when we use 95% as your confidence level, the expected significance level will be how much?
5%.
5%. Okay. And this one, again, represents a p-value. And p-value of what? Kaninong p-value itong margin na to?
Population.
Population. Okay. So your p-value is otherwise known as your
Critical
critical
value.
value. No? But I don't mean na parehas yung they are different in terms of they have the same value, but they have the same meaning. Your critical value can also serve as your margin, okay, like your p-value of the population. Your critical value can also serve as your margin that will mark or indicate the margins of rejection, the critical value. So that when you do your test statistics, you come up with a calculated value. So instead of using your p-values to compare with the p-value of the population, you use the calculated value and compare it with the critical value. Ito ang catch nito. Did you notice that your p-value, as you go away from the middle, or as you go away from the population, your p-value gets smaller and smaller and smaller, right? So if we began with 0.05, then it can go to 0.0 1, 0.001, 0.0001, 0.0001. So ibig sabihin, your p-value, as you go this way, you're going away from your null hypothesis or you're going away from your population, it becomes smaller and smaller. So as your p becomes smaller and smaller and smaller, the more evidence you have to reject your population. Tama? Are you still with me?
Yes po.
Okay, so if your p-value becomes smaller and smaller, meaning you are going farther or away, farther and farther away from your population,
Critical value.
from the critical value. Okay. But in your critical, if you use the critical value and calculated value, it is the opposite. Okay. So do you still remember the z-score? Okay, the z-score, if you are using the z-test, for example, is usually equivalent to your standard deviation. But in some other tests, like for your t-test, when we say t-score, is not necessarily equivalent to your standard deviation. You still have to find the appropriate value for your score, okay, if you are using the t-test. But in z-score, sometimes we say 1 standard deviation is equivalent to 1 z-score. 2 standard deviation is 2 scores. 3 standard deviation is 3 scores. So your z-score will serve as your critical value. Okay. So for example, hypothetical lang to ha, hindi siya exact value. If your critical value is established at, di ba? So these are your standard deviation and it comes with the same score. So 1 z-score, 2 z-score, 3 z-score, 4, 5, 6, 7, and so on and so forth. And on the other side, that would be -1, -2, -3, -4, -5, -6, and so on and so forth. Okay, look at the distribution. So if we are talking about the critical value and the calculated value, example, if I give you the, we are using the critical value, which is 2. And then it so happens your test statistics or your sample will give you a calculated value of more than 2. Let's say 3. Okay. Where can you find your calculated value in terms of that distribution? Saan mo siya makikita dito?
Outside.
Is it here or dito?
Outside.
So probably this is 2 and
The
your
right.
calculated value is nandito. Okay. So nasaan siya? Is it outside or inside?
Inside.
Outside.
Okay.
Outside.
Inside.
It is outside. So when your calculated value is more than your critical value, you will be prompted to reject the null hypothesis. Okay. Sabihin natin yung calculated value mo nag-increase, naging 4. Nasaan na yan yung calculated value mo?
Outside pa rin.
Outside
Inside.
pa rin. And it
Outside.
became even further, right?
Mhm.
So as you increase your calculated value, meaning to say you get further and further and further from the margin or from the null hypothesis or from the population. So if it gets higher and higher and higher, your calculated value gets higher and higher and higher, this will prompt you all the more or will give you more reasons to reject your null hypothesis. You get my point? Do you agree with me?
Yes, sir.
Okay. So again, your calculated value, as it gets higher and higher and higher, it means you get further and further and further from the margin. So all the more now you're going to reject your hypothesis, your null hypothesis. Take a look at your P. as you go further and further from the margin, does it go higher or lower?
Lower.
Lower. So this is the trick. This is the tricky part kasi when you are trying to make a decision. So be careful if you're going to use your p-value to interpret or to make decision, or you're using your calculated value in making interpretation, because you might be misled, no? So yung p-value, as it goes lower and lower, the more reason for you to reject. For your calculated value, the more it gets higher and higher. It means the further and further you get from the margin, so the more reason for you to reject. So parang inverse sila, magkabaliktad. So that when you make decisions, you have to take note of this difference. Okay. Are we clear on that? Are we clear on
Yes,
that?
po.
Okay.
Yes
Yes
po.
So that when you will be able to establish your the next thing is, we have stated the confidence level, right? So you can select from the empirical value, but again, I say it is necessarily coming from the empirical value all the time. You can select what, level of confidence you want. Okay? So that if you know your confidence level, in turn, what are the other informations that you can get once you will be able to identify or give your level of confidence?
Level of significance.
Okay, so at the same time, when you will be able to express your level of confidence, in so doing, you are also giving the value of your significance level. Okay, so if this is 95, the significance level will be
5.
5%. Okay, and when you do this, you also can get the value of your P. Okay, so this way, which is otherwise known as the alpha value, so the P value then of a 95% level of confidence, 5% significance level will be
0.05.
0.05. Okay, so by doing this, your P value has a corresponding critical value. Where do you get this one? You use a table of reference. And in this case, if you are doing a z-test, you use the z-table. So when you use the z-table, you can get the equivalent critical value of your p-value. So for example, for 0.05, I think the critical value in a z-test is 1.96. So madederive mo siya. So there will be equivalent values for every p-values, for every significant values, for every confidence level, right? So you will now have the answer for number 3, because you just simply state your significance, your confidence level. And when you state your confidence level, you can now also determine your significance level, your p-value, and your critical value. Am I right? By just knowing your confidence level, you can also arrive to the values of your level of significance, p-value, and critical value. Diba? If you trace this down, you will be able to generate a critical value by just basing on the confidence level. Okay. And this critical value will serve as your, again, kanina, your critical value will serve as your
Margin.
margin, okay, for decision. So any value beyond or within that critical value will prompt you to a certain decision, whether you're going to reject or you accept your null hypothesis. Okay? So far, so good?
Yes po.
Okay, so we're done with step number 4. After establishing your critical region of rejection, so nakapagsabi ka na, ito yung magiging margin ko. In this, at this point, it should be 0.05, which is equivalent to a critical value of 1.96. So what's missing now? Ano pa ang kailangan mo?
Sample value.
Okay, so you now proceed to the next step, which is to find the value of your sample. Kasi ito, na-establish mo na yung value ng population or yung null hypothesis. What is lacking now is the value naman of your sample. So that you're going to do some statistical testing in order to arrive at the value or a calculated value of your test sample, or otherwise the p-value also of your sample. And once you get that, you are now ready to make a decision based on a decision rule. Wherein, di ba, ang decision rule natin, if you are using the 95% level of confidence, then any value more than 0.05 will prompt you to what? What will you do with your null?
Accept.
Accept. Okay? So any value that is less than 0.05 will prompt you to what with your
Reject.
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 Okay. So now you were able to perform decision making that is based on data or your number or your test statistic. So you will decide based on the result of this statistical test that you're doing. And then now you are ready to make a conclusion. So that if you reject your null hypothesis, what will be your conclusion?
There is no
There is
A
difference.
has
There
no
is six.
difference. Okay? There's no statistical or significant difference between two samples that you're trying to compare. If you accept, if you reject your null hypothesis, okay, this means that A and
There
B
is
are not the same. So there is a difference between A and B. Okay? So that is hypothetical testing in summary. Okay. Are you confident now to do your hypothetical testing? Do you know how to do hypothetical testing already?
Yes.
Yes. Very good. Ganon ang sagot. Ganon ang sagot, Edel, kahit hindi mo medyo maintindihan. Yes pa rin. That remains to be tested, di ba? By hypothesis testing. Anyway, so in summary, this is the process of doing a hypothetical testing. Don't worry, we will go through these steps one by one in detail. Okay, so again, let's memorize. What's the first step of hypothetical testing? Don't look at the slide. Number one,
Organize data.
organized data.
organize and identify your data. Next,
Hypothesis.
The
Null and alternate hypothesis.
The
okay,
null and
establish your
alternate
hypothesis. So after your hypothesis, what happens next?
take the
State
level of
the level of
significance.
confidence level.
State your level of confidence. Okay, after identifying the other factors, confidence level will give you the p-value anyway, will give you the significance level, and it will also give you the critical value of the population, right?
Yes.
Okay,
Yes.
now, what's next? You know information about the population already. What's next? You're going to find out the values
Statistical
of
test.
your sample
Sample.
using statistical
Calculated.
test. Okay. In your statistical test, what do you aim for? What are your goals? What do you want to know when you use your statistical test? It will be the value of
P-value
The sample.
Of the
the
sample.
p-value of the
The
sample
sample.
or the calculated value of your sample. Why is this important to know the p-value of the sample or the calculated value of the sample? Because
To make a
For
decision.
decision
yes, you are
making.
going to use this value compared to each other and eventually make a sound decision. And that decision will be either to
Accept or
Accept
reject.
or reject.
Accept
Accept
or
or reject.
your null hypothesis. I mean, null hypothesis. So, nakita nyo ba minsan hindi parang salipusan na lang si alternate? Because ang pagtututukan mo is just how to reject or accept si null hypothesis. So that in consequence, okay, the fate of your alternate hypothesis depends on your decision on your null hypothesis. So that when you reject your null, alternately, you're going to accept your alternate hypothesis. But our focus is to either reject or accept your null hypothesis. And your null hypothesis will represent your population. Okay? This is your null hypothesis, saying that your sample is the same with the population. There is no significant difference. That you can safely or generalize that the characteristic of the sample can represent the characteristics of the whole population, and vice versa. Okay? You get the point? Are you still with me?
Yes, sir.
Very good. So let's start with the different steps in hypothetical testing. When I say you organize your data, what I mean is you should be familiar with your data, because by knowing the type of data, what type of data you have in hand, this will dictate you again your choice of your statistical test. When you need to plot your data in a curve, okay, and then you have to identify the distribution. That's the first thing you do when you want to organize your data. Know the distribution pattern of your data, whether they will resemble a normal curve or an abnormal curve with skewness to right or left, whatever it points to. Okay? Because a normal curve has an equivalent statistical test that is appropriate for this type of distribution. And there is appropriate statistical test also designed for abnormally distributed data. Okay, so now you realize the importance of determining or identifying if your data are well distributed or not well distributed or abnormally distributed, because it dictates the choice of your statistical test. So the second thing that you need to do when you want to organize your data is you have to identify the type of data. When you say the type of data, again, can you still remember the qualitative and the quantitative types? Particularly the interval, the ratio, the nominal, and the ordinal measurement or data, right? Nominal means
Numbers.
categorize. Yes, you just put them into group. Ordinal is,
Order or rank.
yes, you
Or
put
rank.
them into rank. And the question is, the difference between ranks, do you know the value between ranks? First honor,
No.
second honor, magna cum laude, summa cum laude. There is rank, right? You know that one is higher from the other, right? But do you know the difference between a magna cum laude and a summa cum laude? Or first to finish, second to finish?
No.
No, you don't know the value in between, or there's no exactness in the value in between. Siguro ang magna cum laude, nakakuha siya ng 95%, yung summa cum laude 94.5, tapos yung third honor is nasa 90. Okay, you know that first honor is higher than the second honor, but the difference in between is not always the same as the succeeding rank. So ibig sabihin, you are not sure of the value in between. While if you say it is an interval and ratio, this is also a rank data, but you know the values in between, right? Like for example, if this is centimeters, you know that 1 and 2 has 10, 2 and 3 has 10 millimeters each. Okay? You can compute for the value 1 plus 2 plus 3 will be equivalent to 30 millimeter. Okay. So as your ratio data, ganun din. The difference between an interval and ratio data then will be just by the definition
value
of what?
zero.
True value of 0.
Zero. By the definition of zero. Meaning to say, in an interval data, zero has true meaning or no true meaning? Interval data. Zero has or has no?
No true meanings sa
No
interval.
true meaning. Okay, this is exemplified by your temperature. Meaning to say, in an interval ratio, interval data, like your temperature, zero does not really mean zero. It has a value. So the true meaning of zero is not applicable in an interval type of data. While your ratio, when you say zero in a centimeter, it means nothing. Zero. Voila. So it resembles the true definition of zero. Do you agree?
Yes po.
Okay, very good. So the next thing that you have to do when you organize data is to know the number of samples that you are studying. Okay, in this sense, you should know the number of samples that you are comparing or you are trying to seek relationship with each other. Okay? Am I comparing one sample to another sample, one sample within this sample, or one sample to the population? So you have to identify ilan. Am I comparing group 1, group 2, group 3, group 4, group 5, that it is more than 2 samples, 1 sample, 3 samples? Because again, this will dictate the statistical test that you're doing. Okay, so if you will be able to organize your data, that will prompt you to proceed with the second step of hypothetical testing. Okay, so what is the second step of hypothetical testing? What?
Null and
Make it,
alternate.
make it a last song syndrome sa utak nyo na kahit anong ginagawa nyo, automatic yan. Alam niyo yung step. That's why I keep on repeating and repeating. Kasi I want it to be very familiar with you. No? So the second is you state your
Establish your
hypothesis.
null and
Okay. So again, you're familiar, no? The null hypothesis, the hypothesis comes in two forms. Your null and your alternate hypothesis. Your null hypothesis is the one we are going to use in decision
Making.
not the alternate. Okay? Alternate will come after the fact. Ibig sabihin, once you rejected your null hypothesis, then you are left with your alternate hypothesis. Okay, but if you accept your null hypothesis, you will not even look at the alternate hypothesis. So ang focus natin in decision making is either to reject or to accept your null hypothesis. Okay. So that when you reject your null hypothesis, okay, this is the curve again. When you reject your null hypothesis, meaning to say papunta ka doon, the more and more and more and more evidence, okay, of rejecting your null hypothesis. Okay? So pag mas marami kang evidence to reject the null hypothesis, then you are going to reject your null hypothesis and alternately you are going to accept your alternate, and the other way around. So if you have less and less and less evidence of rejecting it, then you will be prompted to accept your null hypothesis and leave your alternate hypothesis alone. Okay? Do you agree with me?
Yes po.
Okay, so null
Yes po.
hypothesis is just a answer or a temporary answer which claims no difference okay, between two measures. Your central tendency, for example, your measures of dispersion, for example. You are just trying to say that there is no difference between A and B. Okay. Value alternate hypothesis, we're saying that there is a significant difference. Rather way. I use this one again. It should be like, okay. When you accept your null hypothesis, this means there is no significant difference. When you reject your null hypothesis, this means these two variables are different from each other. I mean, statistically different or significantly different from each other. Okay? Yeah. So if you want to make your alternate hypothesis having a direction, okay, instead of using this one, you're going to use this indicators. Okay. When you want to say that there is no difference, A and B. If you want just to show the difference without any intention of any direction, you just say A and B. And when you do this, you are just after the difference between A and B. This becomes what type of alternate hypothesis?
Two-tail.
Two-tail. But if you want direction, like for example, if you want to see if A is higher than B or there is more difference, okay, A makes compared to B, then you are showing your direction, greater direction. You want to know which one is bigger, which one is taller, which one is greater, for example. So this one is your sign. So A, your alternate hypothesis will be A is greater than B. And this is on the positive side. That's why it is called what? Right tail.
Right tail.
Okay. If you want to see the difference, if A is less than B, directing towards which one is lesser, which one is smaller, for example. So you are directing to the right. So lesser and lesser. So you are pertaining to this probability, and so therefore it is called left tail. Are we clear? If you don't mind, or if you are not after which one is bigger or lower, then use
Two-tail.
two-tail. But if you are particular with differences, you use either a right, if you want to know which one is greater. If you want to know which one is lesser, you use the right tail, the left tail rather, okay? And your statement of hypothesis will be A is less than B. Or if you want a right tail, A is more than B. Are you still with me?
Yes, sir.
Very good. So let's
Yes
proceed.
po.
So actually, ito pa rin. It is your null hypothesis which you're going to reject or to accept. So that your alternate, what does your alternate role will be? Standby. So that when you accept your null, then you may disregard your alternate hypothesis. And then when you reject your null, then that comes the alternate hypothesis. So that you will now accept your alternate hypothesis. Okay? Maliwanag? So I just would like to remind you, when we are doing hypothesis testing, that when you reject your null hypothesis, it does not necessarily mean that your null hypothesis is true. What we mean by that is just there is just more and more evidence that your sample resembles closely to your population. And when you reject your null hypothesis, it does not necessarily mean that your null hypothesis is false. It only means that your sample has a lesser and lesser and lesser similarity to your population. So it is not an absolute value. So it is a range wherein we are going to consider the similarity of your sample and your population. So that when I say the percentage of sample is 80 and the percentage of the population is 85, okay, this seems that there is a difference of 5 points, right? Okay, but when you statistically find out that 80 does not differ from the 85, then maybe this difference of 5 points can be blamed to sampling error na pwede mo siyang tanggapin. So, okay, kung sinabi mong 80 at 85 ay parehas, so be it. Meaning to say, the difference na 5 points will not be taken into consideration because this difference is only due to an acceptable sampling error. So that when you say naman the otherwise, na yung 80 and 85 and it is statistically tested and your statistic will point out that they are different, 80 and 85, the 5 points there cannot just be blamed with a simple sampling error. So this should be taken seriously, that these 5 points actually represents a significant difference, which is the reason for the dissimilarity. So you cannot just accept that na similar sila. So you have to get serious and accept that 5 points is 5 points away from 80. Not like when you accept your null hypothesis, that 5 points does not necessarily mean a difference from 80. Okay? Are you still with me? Are you
Yes,
still with
sir.
me?
Yes po,
Yes
Doc.
po.
So any question with the null and the alternate hypothesis? With none? If none, let's proceed to the third step. Again, what's the first step?
Organize
Organize data.
Second step?
state the
Take the null and
hypothesis.
alternate
Third
hypothesis.
step is you're going to
confidence level.
give your confidence level. Again, this is early. You have to state your confidence early in the game. Okay, before you go into the process, you should state your confidence level. Okay, where will you going to get your confidence level? How can you make your confidence level? You have the option to use empirical formula. Okay, in social sciences, it is acceptable to use the range between 90% and 99% or 99.7%, whatever you want. Okay, basta should not be below 90. Okay, 90 and above is the acceptable range for social sciences. Okay, so nandyan si 90, nandyan si 95, nandyan si 99. So just to make things easy for you, because for every empirical confidence level has their own corresponding significance level, their corresponding P level, and their corresponding critical value. So wag mo nang pahirapan yung sarili mo. So you can choose your confidence level. So at this point, for example, you choose 95% as your confidence level. So what will be your significance level?
5%.
5%. Okay. So what is your statistical significance? 5%. Okay. Your p-value will be 0.05. So Again, makikita niyo yung pattern, no? So meron na siya talagang corresponding value. You don't need to compute. Where did these values came from? It is computed, no? So to avoid the computation, you can use this one. Again, 95, because automatically you will know that a 95% level of confidence is equivalent to a significance level of 5% or an alpha or p level value of 0.05. Okay. Again, um, which one is being represented by your confidence level, significance level, statistical significance? Your confidence level represents your
P-value population.
of the
Population.
population. Okay. So this is how it looks like. Again, palagi niyong nakikita ito. So this is the confidence level. So for every interval or for every standard deviation or for every calibration or for every measurement, there is a corresponding percentage, okay, which we call confidence level. So when you have one standard deviation plus or minus, it is equivalent to what percentage?
68%.
Two standard deviation plus or minus, equivalent is
95%.
95, and so on and so forth. Okay. Remember that always. So how do you compute for the confidence level? You can use the formula of 1 minus alpha, or the other way around. Kung ang alam mo naman yung confidence level, that would be 100 minus your beta. Means this one is beta value. This one is the alpha value. So just do the math. Huh? Kung ang given is yung alpha, then you just have to deduct it from 100 to get the value of your beta. If you know the value of your beta, you just deduct it again from 100, and that will represent the value of that missing item. Okay? So it always resembles 100% or a value of 1 alpha. Just in case you are asking where this number came from. Okay? So that in the use of your empirical level, again, you don't need to calculate them because constantly you have the values of each measurement for each standard deviation. So that if you use the standard deviation of 2, which is equivalent to 95%, automatically the p-values is 0.05 and the level of significance is 5%. So if you use 99% also, it is equivalent to 3 standard deviation with a p-value of 0.01 and the significance level of 1%. So where did this came from? Let's take for an example. Your standard deviation is 2. The intercept is this one, 47.7. And remember, this is a composite type of table. You're not using the other one. So you have to multiply it by 2 to make it fully represented, okay, into 100%. So meaning to say, for every standard deviation, simply it has its own equivalent p-value, and you can compute that. Just like the same, when we want to use, previously we wanted to use 1.5 standard deviation instead of using 2 standard deviation, which is 95. I think the equivalent of 1.5 standard deviation is around, ano nga ba? 1.5, 43 times 2. So, equivalent siya ng 43. 2 sides times 2, 86.
86.
Okay. So your confidence level can also be 86 using what standard deviation? 1.5. Okay? So pwedeng hindi ka gumamit ng empirical values. Still, you can elicit the equivalent p-value or the critical value or the z-score, the t-score of that. So no problem. So what does this mean? Okay, take a look at this distribution again. this area from -2 to +2 indicates an interval, right? See this, the interval of this is -2, standard deviation plus or minus 2. And what is the equivalent percentage of that interval?
95%
95. And you call this your
level.
confidence level. You see the red line? The red line indicates margin. Okay, so this will serve as your margin of error or margins of rejection. And this margin is represented by populations P value, or otherwise known as your critical value. Okay. So your p-value and critical value marks the boundaries of your decision. It serves as the margin of error. It serves as the margin of rejection. So that any value that fall outside this margin will prompt you to what type of decision?
To reject.
Reject your null hypothesis. So if your test value will fall within this box or within this region, what would happen to your null hypothesis?
Accepted.
It will be accepted.
Accepted.
So that in terms of terminologies, this is the confidence level, this is the significance level. So anything outside your confidence level will be your significance level. And your significance level is likewise also the value of your alpha or the p-value or the alpha value. Okay? And this area will dictate the statistical significance. Ibig sabihin, so as you go away further and further from the margin, this will dictate your statistical significance. Okay? You get my point? You are now familiar of the terminologies that when we say confidence level, automatically you can correlate with the graph or with the picture and the position where it lies. Correct? That
Yes.
when I say the significance level, automatically you can figure out where it is lying. So that when you plot down your test, the value of your test or your sample, you know where it lies and will help you make a sound decision. Am I correct? Did this
Yes,
help
sir.
you in any way? This picture, look at this picture. Put it in your mind. So that when you make a decision, dito ka magre-refer kung saan mo ilalagay yung value ng test mo. Kung yung test mo, nandito ba yung value ng test mo or nandito? Okay? So, if it is outside, again, you reject. If it is within, you accept. Those are the tricks on how you're going to interpret the values of your tests. Okay, statistical tests. Again, ito, these are the confidence level. The other side will be your significance level. So, confidence level minus 100 minus your confidence level, that will become your significance level. Okay, ano yung 2.5 na nakikita nyo dito? So, if you are talking two-tailed, meaning to say we are focused on both tails. So this will still be 95%. So this will be 2.5 and this will be 2.5. Because your calculated value can be positive or can be negative. So that if it becomes positive yung calculated value mo, so saan ka titingin? Saan may
Alright.
pa-plot? Dito ka mag-plot. Like for example, if you have +3 ang calculated value mo, lumabas is positive 3, saan may pa-plot ito?
Right.
On
To
the
the
right.
right. Okay. And your margin of error, if you are using a two-tail, will be 0.025 here and 0.025 on the other side. But in composite, you will know where it stands. Okay? If it is ang calculated value mo is negative 2 or negative 3 na lang, negative 3. Nasaan si negative 3? To your
To the
right. Okay? And again, this is outside the decision box. So meaning to say, you're going to reject your null hypothesis. Okay. If this becomes your critical value and your calculated value becomes negative 1, where will negative 1 lies? Within
Inside.
or outside?
In.
Within.
Within.
Okay?
Within.
So if your calculated value is negative 1 and you compare it to the if the calculated value is negative 1 and you compare it with the critical value, which is negative 2, meaning to say negative 1 is more than negative 2, right? So again, be careful when you make decisions. Your calculated value increases in number as you proceed to the right. Not like your p-value, as you proceed further, it becomes lesser and lesser. Okay? So be careful when you use calculated and p-value as your decision basis. Huh? Okay. Yeah. So again, ganun pa rin naman yan. So this will be your decision box. Just what it means to say is that from this point, okay, this will be anything more than 0.05. This one will be anything less than 0.05. So meaning to say, as your p-value becomes smaller and smaller, 0.001, 0.0001, the more evidence you have to reject your null hypothesis. Dito siya. So as your p-value becomes smaller and smaller and smaller and smaller and smaller, the more evidence you have in hand, or the more reasons for you to reject or accept alternate hypothesis, the null hypothesis.
Reject.
Reject.
Okay, very good. So I think naipaparating ko naman yung message. So this is how you're going to interpret. Always paint it, no? Sabi ko nga sa inyo, you always put it in a graph, you picture the data para alam mo kung paano mo siya i-interpret. And the interpretation is based on this. Okay? Based on this picture, this is how you're going to position your sample at makikita mo kung anong decision ang gagawin. Okay. Any question? Any question again? This one is also your margin of error, which will be your critical value or the p-value of your, which one? Again? Critical value, p-value of what?
Population.
Population.
Okay. So iba din yung sample. So what do you call the value of your sample?
Calculated value.
Calculated value. Okay. Then pagbanggain mo lang sila. So you differentiate from itself. Still, this is your decision rule. Okay. So that if your values stays here, meaning to say you don't have enough evidence, so therefore you fail in rejecting your region, or you fail to reject your null hypothesis, so therefore you're going to accept it. Okay? Masyado lang nakakalito yung mga pinagsasabi ng mga statisticians. So When you say fail to reject the region, meaning to say you're going to accept the null hypothesis. And this will serve as your rejection region. Okay. So any question? Kung ang tanong ninyo, where did you get? Di ba meron tayong confidence level? Meron tayong p-value? And meron tayong critical value or calculated value. Saan mo kinuha yung critical value na ito? Saan mo kinukuha? Saan mo transmute? From the
Z table.
tables available. Just be careful. If you are doing the C test, there is a corresponding C table that you use. Okay. If you are using the T test, there is a T table that you're going to use. If you are doing your ANOVA, there is a corresponding F table, and chi-square, you have the goodness of fit table or the chi-square table. So just be careful kung saan ka nagre-refer para tama din yung may elicit mong equivalent critical value. So in this case, our example kanina, we use the Z table to arrive at a Z score, which will represent your critical value. If you use the T test, we call that T score instead of saying Z score. But the value of a Z score resembles mostly your standard deviation. Your T score is very, very, very much different from the value of your standard deviation. So that you cannot say one T score is equivalent to one standard deviation. No. Okay? Maraming difference yan. You have to compute for that using the degrees of freedom. Okay? That's why in the formula of a t-test, when you want to elicit your t-score or critical value for your t-score, you still have to use the table using this degree of freedom so that your t-score not necessarily has the same value of your z-score. They are different. So be careful when you try to elicit the equivalent values, no? So you use the appropriate table available. Okay, now, determine the next step will be to determine the critical region of rejection. We did that already, right? Nagawa na natin, di ba? Yung pag-determine ng critical region. So this will just like be identifying your p-values, which will be the margin of error. This can also be called as your critical value. This one will still be your margin of error. So maliwanag na. So you are able to. What have we accomplished? Again, let's start. What have we accomplished so far?
Organize the data.
Organize. Next, we were able to formulate a
Data
hypothesis.
hypothesis.
Next is, we were able to select the confidence level. We preferred to use the empirical test, which mostly in our example, we used the 95%, right? Okay. We were able to elicit the critical value as well. Now we are done with the population. So what's next?
Sample.
The sample. So we'll now go and find the values, the p-value and the critical calculated value of your sample. Okay. This needs the choice of your statistical test or formula. Okay, so when you elicit the value of the calculated value of your sample, you need to do a statistical testing. Okay, so that you'll arrive at a calculated value and the p-value of the sample. Okay, which leads us to a problem. Very, very big problem for researchers. What? Ito yung tanong yata ni Dr. Karen, ito yung tanong mo dati, di ba? How do we select the appropriate statistical test? Nalala mo,
Yes, Doc.
Karen? Ito yung
Yes,
tanong
Doc.
mo sa akin dati. So, paano tayo mamimili ng appropriate statistical test? Napakadaming statistical test. So, ano ang appropriate na test na pipiliin natin? Okay. I want you to remember 3 points. Okay. So, before that, when you say statistical test, now you are going to explain the behavior of variables, meaning to say your samples or your test statistic, and extend them to the population. So ibig sabihin, you have to study the sample and make a generalization or a conclusion or an inference that the characteristic of the sample is also the characteristic of the population. Okay? So that's what we are going to test in statistical testing, or the other way around. That the criteria or the characteristics that you found out on your sample does not fit the characteristic of the population. So if it fits, meaning to say, what are you going to do with your null hypothesis?
There is no accept.
Accept.
Accept. If the sample is different from the population,
Reject.
you reject. Okay, that is the goal of statistical testing. You test the significant differences or relationship between these variables. Okay. So there are two types of statistical tests that you can choose from. One, we have the parametric group, and the other one is the non-parametric group. Example of your parametric group are your t-test, your z-test, ANOVA, which is the most common and the most appropriate for your level. I think this will be the appropriate test that you will frequently encounter. There are others like MANOVA, regression, correlation. So we can touch these topics naman. For the non-parametrics, it is well represented by your chi-square. Pag sinabi mong chi-square, this is a non-parametric. Your t-test, z-test, ANOVA, regression, correlation, are your parametric tests. Okay. So that in your hypothesis testing, again, you start with an assumption that the null hypothesis is true in the population, and then you use a statistical test to assess whether the null hypothesis can be rejected or not. Okay, so your statistical test will determine where your sample data would lie on an expected distribution of sample, so that you can say if the null hypothesis were true, okay, or not true, so that it will prompt you to reject or accept it. Okay, and this is called your test statistics. The value that you are going to use to decide whether to reject and accept are called test statistics. Okay, and your test statistic aims to provide the calculation of your population's p-value or critical, and for your sample p-value or the calculated value. Okay. So these statistical tools are performed to compare either one group or one sample towards a population. So kumuha ka ng representation of this trend, make them a sample, and then study it if the characteristics of these samples that you get can also represent the rest of the population. Or you can also study one sample, okay, and then study them in different occasions or in different times. Like for example, yung weight ninyo, okay? Weight ng buong class ninyo. So, ang average weight nyo is, ng buong class nyo ha, Group A. Group A. You tested the average weight, let's say, 80 kilograms ang naging average weight ninyo. So, you subject this same group into dietary modification, for example. Okay. Then this same group, you will weigh them again after some time. Let's say after 3 months, after 4 months, you get again the weight of the same people you measured before dietary modification. Okay. And it came out that after 3 months, your average weight went down to 70 kilograms. Okay. Now, The purpose of your testing, hypothetical testing now is you compare your 80 kilogram and 70 kilogram if they differ from each other significantly, that you can say that dietary modification has a role, okay, in the differences of your weight. Using the same sample, kayo pa rin. Hindi tayo kumuha ng iba. Hindi natin kinumpare sa population. We compared among yourselves. So that's what called sample within sample. So this is sample towards the population, sample within sample. Or you can also compare two different groups that are not related to each other. So you group 1 and group 2. So your other group can serve as a control, for example, and the other one will be the test group. And then again, the result of this, you will compare to the other group that they are not related. Okay? So we call that an independent t-test or z-test, or you can call them other names. So we will come to that on how we can classify. Okay. So let's go back to decision making. In choosing your statistical test, it is very important to remember three things. You cannot proceed with your choice of statistical test without knowing these three important factors. What are these factors? Number one is your data. Again, you have to determine if it is normally or abnormally distributed, whether they are categorical or qualitative, quantitative, whatever. Because it will also dictate the choice of statistical test. Okay. The second thing that you have to put in mind or to identify is how many sample are you studying? Are you comparing one sample to another sample, or multiple samples at the same time? Okay, again, this will dictate the choice of your statistical test. And the third one that you have to consider is relationship. What are you trying to do with your testing? Are you trying to compare one from the other? Or are you trying to elicit if there is a relationship between one group to the other group? That when you change the characteristic of one group will also result to the changes on the characteristic of the other group. Okay? And will that relationship can be quantified? That if you change one group into a certain measurable degree will also result to a quantifiable degree of change on the other side, on the other group that you're trying to compare. Okay? Because that, again, will dictate the choice of your statistical test. Again, when you choose your statistical test, you have to consider three things: data, number of sample, and the relationship that you want to convey or you're trying to find out. Okay. When we say data, again, of course, it is imperative for you to identify whether it is nominal, ordinal, interval, or ratio. This will affect the choice of your statistical test. When I say sample, you have to determine if you are comparing one sample within a sample, you are comparing two samples, or you are comparing two or more samples. Again, this will result in your choice of statistical test. Next, when we say relationship, what is your objective? What do you want to inform your reader or the people that were going to read your research? Okay, are you trying to compare variables that A is equal to B or A is not equal to B? Or are you trying to show that any changes of A will result to changes of B without eliciting causation or the reason or the degree of changes that it will make to the other variable? Or are you trying to elicit a causation, meaning to say you are trying to identify a cause and effect that when you change the measurement of your A to a corresponding degree, will it result also to a corresponding change in terms of a value to the other variable? So meaning to say, for every 2 degree increase of A, will it result also to a 2-degree increase of B? That's how your relationship in terms of cause and effect means. But if you're just trying to say that A, any movements of A, regardless of the value or the quantity it makes, you are not after that. You're just after the changes in the movement of B whenever A moves. You don't quantify. But if you quantify the degree of movement of A and the degree that it will cause to the other variable or to the other sample, then you are using causation. Again, the type of relationship that you are trying to arrive at will, again, dictate the choice of your statistical test. Okay. Are we clear on that? Maliwanag?
Yes.
Okay.
Yes,
Yes,
po.
Doc.
Sir.
Again, ulitin natin. The choice of your statistics will be affected by 3 factors. Very important 3 factors. What are these 3 factors? 1,
Data.
data. You have to identify what type of data you have. The second is
Some
Number of
the
samples.
number of sample you are dealing with. And the third, and one of the
Relationship.
important, the relationship
Relationship.
that you want to do with your data. Are you comparing them, or are you just trying to show a cause and effect or a relationship? Okay, so let's go to your data. So your data again can be classified as nominal, ordinal, interval, ratio, because your statistical test is classified as parametric and non-parametric. Okay, so your parametric are designed for, number 1, normally distributed data. Okay, remember that. Second, when your sample size is large. Meaning to say, mas large scale ito. Okay. And the third one is, your variances are similar. Ibig sabihin, more homogeneous yung type of data mo. The values are closer to each other. Mas konti yung mga variance, yung mga outliers, no? Hindi magkakalayo kumbaga yung scores nyo. Your scores tend to fall at the center. Okay, or in one place. So, meaning to say, yung scores ninyo almost resembles each other. They are homogeneous. They come close to each other. So those are the requirements when you're going to use a parametric test. So your parametric test is designed for a normal distribution, large sample size, variances that are similar, and these are appropriate for interval or ratio data. Okay, the most common example are your t-test and your c-test, your ANOVA, regression, and the correlation path. On the other hand, a non-parametric are designed for either normal or abnormally distributed data, which are ordinal and nominal type. Okay? So your non-parametric are not particular with the distribution of your data. Okay? When they are normal, but you are using ordinal and nominal data, you're going to use your chi-squares. When they are normal, but they are using interval and ratio data, what type of test, group of tests you're going to use?
Nova.
Parametric test. Okay. The most common example of your non-parametric test is your chi-square. Okay. So, ito yung pag-aaralan natin on how to perform the statistical test later on, kasi these are the most common type of test that you'll encounter. Okay. And when we say sample, be mindful if you are comparing 1 or 2 sample. Because if you have only 1 or 2 sample to compare, the most appropriate test is your z-test or your t-test. Okay. The difference between z-test and t-test, there is also a condition. Z-test is used for more than 30 data sets. For t-test, for less than 30 data sets. Still within 1 or 2 sample comparison. You're comparing 1 or 2 samples, but in the data set of each group should not be less than 30 if you it should be less than 30 if you use the t-test, or more than 30 if you use the z-test. Okay. When we say 2 or more samples, so group A, group B, group C, you're trying to compare the difference of this. Ilang samples to? 3.
Three.
Will
More
your
than-
test and t-test appropriate for this?
No.
No, why?
It's more than
Two
3.
samples.
It's more
Two
than 3.
samples.
So that in situations wherein you get 2 or more samples, you better use your ANOVA. Okay? If we talk about
Yung more than 30, sir, is it combined for the Z-test and T-test?
no, for each group.
Each group. Okay, each sample.
So, kunyari, group 1 has less than, should be 30 data sets or 30 samples. Yung baka minsan kasi kaya tinutubo ko yung sample. Sample meaning to say the group. Ha? Yung ito naman is the data set. Baka ma-confuse kayo doon. When I say comparing 2 samples, 2 variables, 2 sets, okay, wherein your requirements here of more than 30 means your data set within that group. Okay.
Thank you.
Proceed. 2 variables when you're trying to compare 2 variables, okay, that are interval and ratio, what test you're going to use?
T-test or t-test.
Again, if you are trying to compare 2 variables that are interval and ratio, what are you going to use?
T-test
Ano?
or t-test.
Z-test and the t-test, right? So if it happens to become nominal or ordinal, you better use your chi-square test. Okay. Are we clear on that?
Yes, sir.
Okay. These tests are, your z-test and t-test are used for comparison. Your chi-square can also be used as comparison or to show a relationship. You will see that later. Okay. So that if we say relationship, when yes,
Sir, excuse
when
me, sir. Apo. Sir, regarding the ANOVA and the ZNT test, sir. Kasi yung
I'm sorry, Doc, when? ANOVA and?
ZNT test, sir.
Yes.
Because you can use ZNT test for 2 samples.
Yes, it
Is-
can overlap.
It can overlap, sir. Pero if it's more than 2,
If more than two, definitely you can use your ANOVA.
ANOVA.
If 2 samples, you have the option to use the Z, the t-test, or the ANOVA. But better you use the Z-test or the
Or the
t-test.
T, depending on the number of samples.
Yes. And anyway, if you use the ANOVA, it may not come to exactly the same statistic or number result, but somehow the effect of your decision making will fall into that interval, and still
Okay, sir. It will still approximate, sir.
Yes, it can still approximate. Not too far. So your decision making will still be applicable to that. So you can use ANOVA in 2 samples, but if you have other option, then why not use the Z-test and the t-test? Huh? So
Okay,
ANOVA basically for more than
More than 2.
by definition is 2 or more, but
Usually more than 2.
yes, it is
Okay, sir.
best to use for more than 3. Okay.
Sir.
Interval and ratio. Okay. So again, if we say relationship, are you trying to show differences in the outcomes? Then you call that comparison test. Okay. And there are corresponding statistical tests that are considered comparative tests. Okay. But when you are going to assess relationship, this is not the same with the differences. No? Relationship between two variables, you're going to use the correlation test. Okay. If differences, you are comparing differences, you use the comparison sets. So there are equivalent statistical tests there. If you are trying to establish relationship from one variable to another, there are a group of correlation tests that is available for you. Like for example, the chi-square and the Pearson. Okay. But if you want to show the cause and effect of the relationship, then you're going to use the regression test. The most common example is your linear or the multiple linear regression test. Okay, so again, this will affect the choice of your statistical test. So you should be mindful of your objective. What do you want to show? Are you trying to compare or are you trying to seek relationship? Okay. So for the comparison test, the most common example are your z-test, your t-test ANOVA. For correlation test, this will be the chi-square, the Pearson-Spearman's, and for regression, we have the simple and the multiple linear regression. So it is summarized here. So if you want to compare, choose among these tests. Okay? Meron naman tayong mga requirements, no? When to use them. So your z-test and t-test for what type of distribution?
Normal.
Normal. Okay. What type of data?
Interval and ratio.
Interval and ratio. Yeah. Okay, so meron tayong mga requirements. Your ANOVA and the number of samples?
Two or more.
One.
Two.
So that when you use your ANOVA, what type of distribution is for ANOVA?
Normal.
Still for normal. The type of data?
Normal.
Will interval.
Interval.
But the number of sample is?
4 more.
Two or more.
2 or more. Okay. So when you try to establish relationship, the most common that you can use is your Pearson's, your Spearman's, or your chi-square. Pearson is when you try to see relationship between A and B. If they are directly related to each other. Pag nalungkot ba si girl, malulungkot din ba si boy? Or pag naging masaya ba si girl, malungkot the other way around? Okay? The inverse, the opposite of what girl is feeling towards the boy. So you're just trying to establish relationship. And you can use the Pearson, Spearman's, and chi-square. Your Pearson is appropriately for what type of distribution?
Non-parametric, ano ba?
Normal.
Normal.
Okay, it's also for what type of data?
Interval and
Interval and
ratio.
ratio.
Interval and ratio.
But the purpose is to establish relationship instead of comparison. Relationship meaning, are they directly related, inversely related, or no relationship at all? So this will be exemplified by your R positive 1, R negative 1, and R equal to 0. Meaning to say, if your R coefficient correlation is positive 1, any values, then A and B are related. If your R, this will be your calculated value. Ito na yung test statistic na gagawin ni Pearson. Ang magiging result niya is to come up with the values of this distribution. If it is negative 1, meaning to say A and B are not directly related to each other. And if you are having a 0 R, meaning to say your R, A and B has no direct relationship. They don't mind each other. Okay? They are not relative to each other. Okay? When you say Spearman's, these are the type, ganun pa rin, they are for this type, but these are for monotonous. Ibig sabihin, same sample. And your chi-square naman is also a test of independence wherein your distribution is normal or abnormal?
Abnormal.
Abnormal or normal. It is not dependent on the distribution, right? You can use a normal or an abnormally distributed data. But what type of data? These are for
Nominal or ordinal.
ordinal or nominal. Okay? So you can see now the difference. Pearson's is for, so these are parametric, and your chi-square is non-parametric. So it depends on your data that you're dealing with. Now, if you want to see the relationship of A and B in terms of degrees of changes, so for every +1 changes of A will also result to a +1 changes of B, then you are trying to establish a cause and effect relationship that is exemplified by the following test, your regression test. And regression test comes in many forms. This can be simple, multiple, logistic, nominal, ordinal regressions. Okay, so usually you stick with the simple linear regression. Hanggang dyan lang naman yung mga decision makings natin magagawin. These are more complicated regression tests. Okay, so are we clear that there are set of statistical tests appropriate for your objective? So it depends on what you want to do in your objective. Okay, so because there is a corresponding sets of statistical tests that you can choose from to arrive at a valid inference. Are you clear with that? Malinaw na?
Yes po.
Again, so this is a table where you can use as a reference when you are in doubt. Okay, if you have two samples, usually when you want to compare the means of group A and group B, like for example the weight, what tests are you going to use? And the type of data are parametric or not? If they are, then you better use your T or Z test, depending on the data set. If it is more than 3 samples, and still you're comparing means, considered as parametric, then you use your ANOVA. Are we clear?
Yes po.
Okay.
Yes po.
So what is a z-test and a t-test then? A z-test and t-test are just subtypes. Okay? They are almost similar to each other. Okay? Yun nga lang, meron silang set of characteristics that you have to consider. But both of them, okay, can able to compare 1 or 2 samples. Okay. When we say comparing one sample test, if you have only one sample that you want to compare, example is your sample in a population, we call that one sample T or Z test. Okay. If you are trying to compare measurements within subject design, kayo-kayo lang, sample within sample, you can call that as dependent or paired sample t-test. If you are comparing two different groups, okay, you have a completely separate measurements and the two groups are unmatched and you want to compare them, then this is called your independent sample test. Paano ang itsura niyan? Okay, the one sample test meaning to say you're comparing one sample to a population. So you use your one sample t-test. If you are trying to compare yourself towards yourself in two separate occasions, then this is called dependent or paired sample t-test. Ito yung sinasabi ko kanina, yung weight nyo ngayon, then nagsumba-sumba kayo and natitignan nyo ang result nyo after. So you are examining yourself, sample within sample, and try to compare the differences ng same sample. Okay. And this is the two different groups that they are not related. And the test that we're going to use is the independent sample T or C test. Okay. Maliwanag? Maliwanag?
Yes, sir.
Yes po.
Very good. So can we proceed to the next type, which is your ANOVA? Your ANOVA, on the other side, is called an F test. This is similar also to your T test and your Z test, except that it tests the difference between means of what? Means
Two or
of
more.
two
Two or more.
or more groups. So yan yung magic word, ha? Two or more groups. Otherwise, if it is only one or two, you use your
C or C.
Z or T.
Dirty.
Okay,
Yes.
because your ANOVA specifically is statistical tools that will be used when there are one or more independent variables and two or more dependent variables. Okay, whereas your t-test will just be a statistical tools that can be used with only one independent towards one dependent variable. Okay, so again, one, this is more. So you are dealing with smaller sample. Your ANOVA is for more than
One.
two sample. Okay. And there are three types, just like your Z-test and T-test. What are the different types of your C-test and T-test again? When you're comparing sample to the population, you call that
One sample.
one
One
sample
sample.
T-test. When you compare yourself among yourselves,
Dependent or paired.
dependent or depend. If you are comparing two groups, you call that
Independent.
Independent.
so your ANOVA has the same set of tests also. There is what we call one-way ANOVA, two-way ANOVA, n-way ANOVA. No? So one-way ANOVA is one factor, two-way ANOVA is two factors or two independent variables against two independent variables. So it will always be more than two. Okay, so you can choose from this one. Usually we stick with the one-way ANOVA. So never mind the other. Otherwise, yung ANOVA testing kasi is a very, very tedious and very, very long computation if you do it manually. No? So I don't see any reason for you to intoxicate yourself with the formula. No? When you can do 3 clicks with your Excel or your apps and you can arrive with the result. Anyway, what we are trying to teach you is about decision making based on the output of your test. We are not after you to be perfect or expert in the computation. So what we want is your ability to decide properly. Okay? So I don't see any reason for you to perfect the formulas. No? So you just ask your statistician. They are the best people to call when you are after the value of your test statistics. Huh? So what you have to do is your statistician will not give you any conclusion, will not give you any decisions. You are going to be responsible for the generation of your analysis. So the thing that we need to learn is the principles on how to interpret your values. Okay. So when you say correlation naman, this is exemplified with chi-square and the Pearson and the Spearman. So this test will determine the extent to which two variables are associated. You are not comparing. What are the possibilities of relationship? Okay? To test whether the correlation in the sample is strong enough to be important or can be applied to the other sets of samples or the population of that. Okay. So the most common example here is your chi-square test. So what does this chi-square test do? This is a statistical tool that is used to compare and observe the proportions of observations falling in two different categories or observed. Like for example, you have a contingency table. Okay. This is your parameters, the observed or the expected outcome, and then the observed. Okay. 1, 2, 3, 4, 5. Student number 1, student number 2, student number 3, 4, 5. You took the national exam. You took a national exam. Your teachers expect you to get at least 80%. Si group 2 medyo pabibo ng konti, so mga 85. Si student number 3 siguro makakakuha yan ng 80, mga tipong mga 83, 75. Yan. So that is the expectations. And then came the result of your exam. So your student number 1 got the score of 74 instead of 80. 85, oh, siya yung naging matalino, naging 89 kung kunyari. Si 80 nag-improve, naging 85. Si 83 nag-deteriorate, naging 80. Si 75 naging 80. Okay. So you're going to test the relationship. You are not going to compare the average mean of this. What you're going to do is you compare the relationship of the expected and the observed. So that yung teacher mo, kunyari, nag-undergo kayo ng review class, okay? So you will try to see the relationship of giving reviews to this test of this student if the expected will be the same with the observed one. Now, okay, you again test for the values of your T and the critical values, and then you come up to a decision wherein you will eventually decide, yes, there is a strong relationship between giving a review class and not giving your review class. So that's how you interpret your relationship or your chi-square. So you will not compare differences, but you're trying to find out if your expectations and the actual are related to each other in terms of a certain manipulation. Again, did review affects the scores of these students? Are they related? So that if you give a review, you expected a higher grade, for example, and the actual settings resembles your expectations. So you're trying to establish a relationship. This is your chi-square test. Okay, and your chi-square test, oh, what happened? Sorry. Yeah. Your chi-square tests are used to determine if there is a significant association between two categorical variables, and they will assess whether the observed is or differs from the expected distribution. Are you still with me?
Yes po.
Okay. So again, comparisons test aims to compare the differences. Your chi-square test, your z-test, your t-test, your ANOVA aims to compare different sets between different sets. Your chi-square test will identify relationship instead of comparing values. How close your expectations to the observed. So is there a relationship in there? Okay? That's why it is appropriately for nominal variables. Okay? Because we are trying to seek relationship. Okay. Am I still with you? Are we clear
Yes.
on that? Okay, very good. So there are two types of chi-square test. We have the goodness of fit test and the test for independence. So if you use your chi-square test using the formula for goodness of fit test, this will determine if your sample data matches a population. So a sample towards a population. So the test is the sample and you see if it fits to the population. Okay. Now, your test for independence will compare two variables in a contingency table to see if they are related. So, ibig sabihin parang group A and group B. Ito, kunyari is test scores ng mga students according to, di ba, minsan iniisip natin yung relationship ng school, kung saan kayo graduate, sometimes has bearing, di ba, with the expected average score in your board exam. No? As is school A, usually they produce a higher average of passing. No? While school B has a lesser one, and then you try to see if the school is related to the expected scores in the national board exam. So that is goodness of fit. But if you are trying to compare a group A lang and group B, ibig sabihin yung kunyari school A, tapos kunin mo yung mga estudyante, group mo sila, group A and group B, and you will try to compare this, then you are just testing for independence. But if you are testing a sample and you are going to see if it is related towards a population, then you use the goodness of fit test. Okay? Because in your Excel, if you're using the chi-square, there is a prompt there that will ask you, are you trying to seek relationship between sample and population or goodness of fit test? So you have to select the goodness of fit test. If you are trying to compare or seek relationship between two groups, then you click for the test of independence. So that is the need of identifying what is your objective in your data. Okay? Are we clear on that with the chi-square? Chi-square seeks relationship. Okay? Relationship between a sample and a population. We call that as a goodness of fit. Relationship between two variables lang. It is called the test of independence. Do you agree?
Yes, sir.
Okay, so we can proceed. Let's talk about Pearson. So Pearson's is what type of test, parametric or non-parametric?
Non-parametric.
Non-parametric.
Pearson,
Parametric.
parametric, because these are ideal for interval and ratio data. Okay, so if your data is in interval or ratio data, okay, whether you want to show relationship, not comparing, so you go away with C-test and T-test because that is not your objective. Your objective in describing your interval and ratio data is to seek relationship, then go for the Pearson test. Okay. What about a Pearson test? The Pearson test is called moment coefficient of correlation. Okay, this is otherwise known as Pearson sub R, rho. We call that rho. Okay. R, small r. This is commonly used for the correlation coefficient. Correlation coefficient, this is the statistical formula that you use when you want to establish relationship among interval or ratio data. So it is the Pearson's test. The Pearson's test or the coefficient of correlation will describe naman or measure the closeness of the relationship between two variables for the purposes of prediction. So this involves any two variables. So dalawa yan, sample 1 and sample 2, kunyari, that happens to exist together. Si boy at saka si girl. Okay? If they exist in the same time or place, okay, and not independent, or they can be dependent with each other. No? So any changes of this will result in a change of that. So the degree of the relationship or association between variables is called correlation. And this will be measured by means of your coefficient of correlation. So your Pearson's test is otherwise known as coefficient of correlation. Okay? There are two types of correlation. We have the Pearson's and the Spearman. Your Pearson's are designed for linear relationship, and for Spearman's for monotonic relationship. So let's go for the more interesting one, for the linear relationship or the Pearson. So what does a Pearson's correlation mean? Your Pearson correlation test is just like your z-test, t-test, ANOVA, chi-square that results to generating a certain value. Okay? This is your p values of your sample. But this time, instead of calling it a p-value or a critical value, it will be expressed in coefficient between -1 and +1, 0 in between. So that if you generate in your calculation, in your coefficient test, the value of R comes between 0 to +1, anywhere in between will dictate positive relationship. If the result of your calculations comes out between 0 and -1, it means what type of relationship?
Negative.
Negative. Okay. If the calculated value will become 0, what type of relationship?
Like,
Wala.
No relationship. Okay? If the value of R is more than 0 to 1, +1, this is positive. If your value is 0, no relationship. If your value of R is 0 to -1, then you are showing a negative relationship. Okay? So the closer the absolute value or R is to 1, so papunta doon, the more positive it gets, the stronger the correlation. Okay? So just keep in mind that correlation does not imply causation, and the other factors may influence the observed relationship. Because if you are trying to imply causation, might other as well use the other type of relationship test, which is your. Do you remember? If you are trying to seek relationship, the degree regression. So yun naman ang gagamitin mo. Kung simple lang ang relationship, you use the Pearson. If you want to identify the degree that the relationship will make, you use the regression test. Okay, so again, if it is interval or ratio data, you use the Pearson test. And this is a parametric test. If it is ordinal, interval, ratio variables, okay, that are monotonous, you use the Spearman. So this is not a parametric test. Or otherwise, if it is nominal or ordinal lang, okay, this is a non-parametric, better use the chi-square test of independent. Okay. Are you still with me?
Yes po.
Okay.
Yes,
Yes.
Doc.
So to explain a little bit further, okay, just tell me if you want a rest, or if we can use this as ano. Ako kanina umaga pa ako nagsasalita. Anyway, game pa rin naman ako. So don't worry. Just on your point of view. If you are tired, just let me know. We can stop for a while. Or if you want it to be continuous, then better so that we will finish early. So let's go back to your Pearson's correlation. This is what your row or your R shows or is being interpreted. Huh? So when you say Pearson's correlation, can you see this one? Sales and shaved heads. Ibig sabihin, siguro yung shaved heads mas presentable yung mga sales personnel ninyo. Okay, maayos silang tignan, no? Naka-makeup yung mga ladies, nakapormada yung mga lalaki. So meaning to say, we are trying to see if there is a relationship between the number of sales and the type of person you have. So meaning to say, if more presentable ba yung itsura ng sales personnels ninyo, will it translate to a higher sale? Okay? So your Pearson is like that. It will show relationship between variables, but it will not show an obvious relationship. Ibig sabihin, gaano kaganda ang maganda? No? Mas makapal ba dapat ang makeup? Mas dadami din yung sale mo? Hindi. We just wanted to know if presentable compared mo sa mas medyo hindi maayos sa sarili, and then you take the outcome, the relationship towards the number of products that are being sold, for example. So you are trying to show the relationship of your sales and the presentation of your sales personnel without any causation or without any establishment of cause and effect. Okay? So if we want to be more statistic, ibig sabihin we speak of numbers, then we will have to compute the relationship. If there is a real significant relationship between sales and being a well-groomed salesperson. So we will subject this to a statistical test called correlation. Okay, correlation is a statistical test that will show the strength of relationship between variables, wherein your correlation means togetherness, and connection is you are testing how they are related with each other. So like for example, this will be translated into a statistical figure or graph. This means sales. This will be your grooming. So the test that we're going to find out if is sales related to the grooming of the sales personnel. So if your data or if your computations looks this way, your R is more than 0 to positive 1. You need to say this is the direction. Okay. So what is the relationship? Positive.
Positively related.
Okay. Positively related. So maybe, totoo nga na when the better the salesperson grooms themselves, they will translate to a higher sale. Okay. So for example, you have weather and selling cold drinks. During summer, okay, do you expect that when the weather is hot compared to the weather when it is winter, what do you expect to the sales of the glasses in terms of glasses, no? Or your cold drinks? No, not in terms of glasses. In terms of the general sales of your cold drinks. Does it mean that if it is hot, will also increase the number of sales? For example, this is your weather. If you increase the temperature, we are not after how much your temperature will increase. No, we're not there yet. We're just after the identification. If the temperature will increase, will it also translate to a greater sale in your cold drinks? Okay, so you computed for the value of R, and the value of R looks like this. Okay, it looks like this. So what will be your interpretation?
Positive linear
So
correlation.
they are positively related. Meaning to say, the hotter the weather, the more sales on your cold drinks. Do you understand? So they are positively related. So if your R is equal to 1, it shows positive relationship. If your R is less to -1, it shows a strong negative correlation. If it looks like this, they are not related to each other. If it looks like this, they are not related. So your R is 0. Your R is 0. Your R is from 0 to +1. Your R here is from -1 to 0. You understand?
Yes, sir.
Okay. Wherein our objective here is only to seek relationship. If there is a significant relationship between temperature and sales. Are we clear on that?
Yes, sir.
Okay, very good. So these are the possibilities if you try to plot your data. So can be positively correlated, pagka ganyan. So this is a very strong correlation. So habang pababa ng pababa, then hanggang sa maging flat. Pag naging flat na yan, there is no correlation. Pag pababa, there is a negative correlation. Okay? And pagka ganito naman, there is no relationship at all. Okay. So your coefficient correlation has also formulas like your z-test, your t-test has formulas. Your correlation coefficient has also formulas. Not unless you're willing to memorize this one, then go ahead. If you're not interested in the formula, it's okay. Because what we are after is just the result of this test. So you are after the result of your rho or your R, whether it is positive, 0, or negative. Okay. And this one has a corresponding p-value, wherein you can also use this one for decision making. Okay? But with this one, just like your calculated value, you can generate a conclusion or a decision by just using the value of your correlation coefficient. But if you want to transform the correlation coefficient into p-values, you can do that by computation, and then eventually you use the p-values instead of the raw values to make a decision. Okay. If you use the raw values to be your decision maker, values of R that is closer to 1 means
Positive relation.
okay, strong or positive relationship. If your rho is closer to -1,
Negative
you
relation.
have a negative relationship. If your rho is equal to 0,
No relationship.
no relationship at all. Okay. Again, this one, you can transform this into p-values. And then again, you can use your p-values to decide if at the very start you use your confidence level of 95%, your population value will be 0.05, and your test p-values will depend on whatever you have. And then you try to compare it with your population values. Okay? So your correlation coefficient will give you the value of your rho or can give you the value of your p. Either or, you can use that to make a decision. Are we clear on that?
Yes,
Sir.
Very good. Very good. So what about regression? How does regression differs from correlation? Sabi natin kanina, correlation just 6 relationship, regression 6 relationship in terms of measurement. So ibig sabihin, there should be a corresponding degree to make a change to the other variable. Okay, like for example, ito, we use again the weather. So now, instead of using the hotter it gets, the more cells you get. So this is for correlation. But if you want to know if for every 1 degree centigrade increase in temperature, will it result to a corresponding increase of 1, 2, 3, 4, 5, 6, 7, 8 glasses of your cold drinks? So meaning to say there's equivalent. So for every 2 degrees increase, then most probably you expect an additional 8 glasses more and it becomes 16 glasses. Okay. Here, you are trying to compare relationship in terms of a value or a degree. Okay. So you are not only seeking relationship, but you are establishing a cause and effect. So for every additional degree of this one will result also for additional degree of this dependent variable. Okay. You get the point.
Yes, sir.
You know now when to use your correlation, when to use your regression, when you use your comparison test, and when to use the other test. Are you comfortable now in your choice of this test? Are you?
Moderately comfortable.
Moderately comfortable. Anyway, it's okay. So again, we don't expect you to become a statistician. With what we expect is you to be a good decision maker. Okay, wherein you will decide based on data, based on numbers. So you will fight with numbers, you will fight with your data so that you will come up to a good decision. Okay. So this is just a table that would assist you in your selection of what type of regression you're going to use. Okay. So one interval, one ratio, and your outcome is one interval, one ratio. Then you just simply use the simple linear regression. So 2 or more, parang ano ba? Okay. You use the multiple linear regression. Okay. So that we come to this data. No? If you are still confused, maybe this table can help you decide on what test you're going to use. So again, the 3 important factors that you have to take note is one, the type of data. Okay.
Number of
Are they
samples.
categorical or quantitative? Next is sample. Is it 1, 2, or more? Okay. 1, 2, or more. And the third is relationship. Are you trying to compare or are you trying to seek relationship? Okay. So that if, for example, you have a quantitative data, you want to compare, and the sample is more than 3, what statistical test you're going to use?
Nova.
ANOVA. Very good. Okay. If you have a quantitative data, more than 2 samples, and your reason is to compare, then you use the ANOVA. Okay? You can also use other contingency table. So ito po pwede niyong gamitin. But still, the prerequisite of your decision making in the choice of your statistical test will still depend on 1, ulit,
Data.
2,
Relationship.
Number of samples.
False.
third is
Relationship.
Okay. So again, if you want to seek comparison on differences on one data or two or more data, then this will lead you to the choice of your statistical test. Okay. So that in this case, if you want to compare two or more samples, then you use your ANOVA and so on and so on. Okay, I hope this will help you decide on what type of statistical test na gagamitin niya. Para ma-impress nyo naman yung statistician. Kasi minsan yung mga statistician, mga ano din yan, loko-loko din. Tatanungin ka, Dok, anong test ang gagamitin natin? So, tinetest ka lang kung alam mo kung ano yung pinifeed mo sa kanilang data. So, pwede mong ma-impress yung statistician. Oh, I want a two-way ANOVA for that. Diba? So sasabihin na statistician, ay, ang galing pala ni Doc, tinatamad lang mag-compute yan, kaya binigay sa akin. Pero alam niya yung mga expectations para sa akin. So, in that way, you have shown your worth to your statistician. So, seryosohin ka ng statistician. Okay? So, the most important thing is the decision you make. Okay? Based on those statistics. Okay? Are we clear on that? Do
Yes,
you
no.
agree with me? Okay. That's nice. So, once you will be able to elicit your value of your statistical test or your statistic or the calculated value, you are now ready to make a decision, which leads us to step number 6. Okay, so decision comes very easy now. Once you have the values of your P, you have the values of your critical values or your raw values, you can easily make a decision without hesitation because you are basing your decision with a concrete result. And nobody can challenge you for that if you fight with numbers, right? So, walang pwedeng magsabi sa'yo mali ang decision mo. Kasi you made your decision based on scientific way of decision making, which is your statistical test. Okay? After making a decision, now you are ready to make a conclusion. So how do you make your conclusion? This is all about rejecting or accepting your hypothesis. Therefore, there is no significant difference, or there is a significant difference between the mean scores of group A and group B given a confidence level of 95%, a p-value of whatever statistical value you were able to get. And that's the way how you're going to present your result. Okay? So when you present your result, you will interpret it as either you agree with the null hypothesis, and then you state the different parameters that you use. You can mention the mean, the standard deviation, the critical value, the confidence level, the p-values of your test. Okay? So that's how you will make your conclusion. So you narrate what you've seen. And at that point, you are now done with your research paper, complete with conclusion and even recommendation. Do you agree with me that we have come to a point that you can now do your own research, complete with statistical decisions and conclusion?
Yes po.
Okay, it warms my heart. Huh? So it warms my heart. At least I don't expect you to be perfect, but you know the principles of doing the decision making. Okay? So there is just one more thing that I would like to mention to you, that when you make decisions in every aspects of our life, di ba? Whenever you make a decision, there is a possibility of error, right? Sana hindi naging ganun ang decision ko. Sana hindi siya ang pinili ko. Sana hindi ganito ang nangyari. Because for every decisions you make in your life, you will be exposed to the possibility of making that wrong decision or that right decision. Okay? What I mean is, when you choose to accept your null hypothesis, when in fact your null hypothesis should have been rejected, then you committed an error. Okay? And there are two types of errors in statistics. So this is the type 1 error or the alpha error, type 2 or the beta error. So if you choose your decision, okay, of rejecting your null hypothesis, you are committing what type of error?
Alpha.
Alpha error or type 1 error. If you accepted the null hypothesis, what is the possible error that you will commit?
Beta.
Beta. Okay? Are you still with me?
Yes, Doc.
Okay. Do you realize the importance of accepting or considering the possibility of error that you will commit when you do your decision making? Because this will result to some implications, or anong tawag mo doon? Kumbaga sa morbidity, unexpected outcome. Okay? So whenever you commit a type 1 error, there is one point or one portion of that decision that will suffer. Okay? Or if you do the other one, the other side will also suffer. Parang it's a two-sided coin. That if you decide to stay on this area, there will be possibility of error. What if kung ang tama dapat dito ang decision mo? Okay. So this will be type 1 and type 2 error. So to exemplify it further, a type 1 error or alpha error, or otherwise known as the positive or false positive error, happens when you reject your null hypothesis. Okay? You rejected your null hypothesis when in actual condition you should have accepted it. And when this happens, when you reject your null, what is the type of error that you are committing?
Alpha
Alpha
Type
error.
1.
F1.
Okay. When you accepted the null hypothesis, when in fact you should have rejected it in the first place, what is the type of error you committed?
False
Type-
negative.
Type
Type 2.
2 or false negative or beta error. Okay. How do you differentiate a type 1 from type 2 error? Anyone from you who can give me an example? Draw me an example that will best represent a type 1 error. Give me a scenario that would resemble a type 1 error of making decision. Anybody? Have you heard about this type 1, type 2 error? Yes. Palaging tinatanong yan pag nagpe-present kayo ng journals ninyo. What is the possibility of error that you committed in your paper? Palaging ginagawa yan kasi kasama yan sa grading. So, possibly I committed a type 1 error. Possibly I committed a type 2 error. So what does a type 1 error mean? Anybody? 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 Nahihiya sila. Nahihiya lang kayo. Okay. Let me explain. Okay. Let's take this as an example. You are the doctor. Okay? You are the doctor. These are your patients, for example. Disregard nyo to. I'm not talking about this one, huh? You are the doctor and you have a patient. And you are giving COVID vaccine. Okay, you give it to your patient. So, nag-antay ka for some months for the effect of that vaccine. And then eventually, you, being the doctor or being the producer or being the one who made the decision, okay, found out na there is a big there is a dangerous effect on the cardiac function if you give COVID vaccine. Okay? So sabi mo, being a doctor, ay, wag ko na lang ibigay ito kasi maraming danger ang pagbibigay ng COVID vaccine. But in the point of view of your patient, they don't feel any. They did not experience any. So meaning to say, they did not saw any effect. There's no effect to them. So according to them, walang effect yung vaccine, walang danger yung vaccine na yan. But you, the doctor, insisted, no, hindi. Merong cardiac problems yan na nangyayari. So withdraw mo na lahat yung vaccines na pinabigay mo. Okay? So, your decision to withdraw the COVID vaccine from the patient is a type 1 error. Type 1 error in the sense that you, the doctor, sees the problem when in fact, wala naman talagang problema in terms of patient. Okay? So, you rejected your null hypothesis that there is no evidence of danger when you give COVID vaccine, when in fact, you said that there is an effect of the COVID vaccine when in fact, wala naman talaga siyang effect sa patient. So this type of decision, you committed a type 1 error. Okay. Let's talk about the type 2 error. Baliktarin natin yung sitwasyon. So si doctor insisted that, sige, ibigay nyo lahat yung mga vaccine na yan. Walang danger ang pagbibigay ng vaccine, sabi ni doctor. Pero si patient, nagkaroon ng myocardial infarction, cardiomyopathy, ang daming nagkaroon ng mga problema. Okay? So the doctor insisted that there is no effect on the vaccine when in fact, meron. Kasi yung patient, sila naman nagsasabi, wag nyo na ibigay yan COVID vaccine nyo kasi marami kaming nararamdaman. So si doctor naman, hindi ako naniniwala, bigay mo pa rin yan, walang vaccine. So again, what did your doctor committed? What type of error? He committed
Ito.
type 2.
False negative.
False negative. Very good. Okay. So you now understand the difference of having type 1 and type 2 error. Okay, the next question is, how much are you willing to accept this type of error? Okay, so sinabi nga natin, it is inevitable. There will always be error in every decision that you're going to make. The question now is, what type of error are you willing to accept? It depends on you. Okay, it depends on your objective. If you are a producer and you're willing to accept the producer's risk na tinatawag natin, kahit magkalugi-lugi ka, tanggalin mo yung vaccine because you don't want to make any side effects to your patient. On the other side, kahit nakikita mo nang may effect sa mga pasyente mo, you still keep on going and giving this vaccine. So who are you putting at risk? Your patient or your consumer. Okay? Type 1 error. Who is at risk with type 1 error? Is the producer or the consumer?
Producers.
The producer, your doctor. Okay? A type 2 error, who is at risk?
Consumers.
Consumer or the producer?
Consumer.
Consumer. Okay, these are your patients. The patients are suffering. Okay, so now, how much are you willing to accept that error? It depends on you. Okay, so kung tatanungin mo ako, which one is better? Which one is more acceptable? It depends on you. Okay, how much willing are you to commit the type of error? If you are willing to commit on the producer's risk or committing a type 1 error, then you stick on the alpha risk. Okay? If you are committed with the type 2 error, then commit with the beta. Okay. So what does this mean? How does it looks like in your decision making? Okay. So again, this is your curve. 0. Okay. So this is the confidence level, di ba? Confidence level. Let's, for example, 2. This is equivalent to, ilan to? Ilan yung
95.
90, sorry, 95. Okay, 95%. Yeah. If you want to decrease your type 1 risk of error or your alpha, what are you going to do? Sabi,
Increase the
natatakot ako dyan
confidence,
sa
yeah.
type 1 error or type 2 error. So I have to increase on my type 1 errors. How would you do that? How would you manipulate your confidence?
Increase the
Yes.
confidence.
Yes, okay? You increase the confidence level. Kung gusto mo, naliliit yung alpha error mo, therefore, you widen or you increase your confidence level. So instead of 95, gagawin mo ngayon siya na 99. Okay. What if you are not willing to commit naman the type 2 error? What are you going to do?
Decrease confidence level.
Yes, you decrease naman your confidence level. So you go for 90 para tataas yung alpha level, nagdi-decrease yung beta level mo. So when you increase your alpha level, you are committed to committing a type 1 error. And if you decrease your type B, still, this is a type 1 error. Or vice versa, if you increase your beta error, you are committed to type 2. And likewise, if you increase the beta, you decrease your alpha, and you are willing to accept a type 1 error. Okay? So you see the difference now on how you're going to decide which type of error you're willing to commit. Yes. Because you have a choice. Depende sa iyong objective kung anong mas gusto mo. Are you on the producer side that you are willing to lose everything in favor of your patient? Or are you willing to gain so much in the expense of your patient? Okay, so you see the differences, no? So most probably, kung in terms of medicine, in terms of COVID, I would like to go on a type 1 error. Kasi I'm willing to sacrifice my money for the sake of my patient. That's why I would decide for a type 1 error. And if I would decide for a type 1 error, I am going to increase my type 1 error and a type 1 or your alpha level and decrease your beta level. Okay. And that goes the other way around. If you are not willing to lose your money in the expense of your patients, and then go ahead, commit a type 2. So when you want to commit a type 2, higher chances of getting a type 2, you are going to increase your confidence level, and likewise, you are decreasing your alpha level. Okay. Do you understand me?
Yes, sir.
Okay. So that to remain neutral, the reason why we keep on using 95 rather than 90, rather than 99, is somehow we are at the middle and we can balance everything. A little bit of this and a little bit of that. Okay? But I'm not saying that you should stick on the 95. Again, the choice of your confidence depends on your objective. What do you want to happen with your null? Okay, are you willing to go on rejection? Or are you willing on accepting it? Okay? But if you are so much so confused of what, then I would rather suggest you stay at the middle to get a little bit of this, a little bit of that. So you go for 95 instead of going 99 or 90. Okay? That's how you're going to balance the possibility of error. Okay? Do you agree with me?
Yes po.
Okay, very good. So, at the end of your paper, possibilities is someone will ask you, what type of error did you commit? What is the possible type of error that you commit in your paper? Then you are ready to answer them. If you have a very high confidence level, what type of error you're committing?
Type 2.
Type 2. Meaning to say, if you increase the confidence level, you are amenable of accepting even the false negative, false positive, kinukuha mo na, nadidetect mo sila lahat. So you agree on getting everything. So your error of saying that it is true positive when in fact it is false positive, pati yun na-include mo kasi winiden mo yung acceptance region mo. Right? Okay. And the other way around, if you decrease your confidence level, okay, you are committing
Type 1.
type 1. So you are willing to accept only very specific. Naging stricto ka. No? So kinukuha mo lang. So chances are you will skip even the true negative, okay? The true positive, kinonsider mo na silang negative kasi napaka-strict mo. Konting pagkakamali lang, pinitik mo na sila. So hindi mo na sila sinabi. So you are doing a type 2 or type 1 error. Yeah. Okay. So the moral of the story is what?
May neutral.
Every decision that you make, there is a possibility of error. Okay? Can be type 1 and type 2. Now, the choice is yours. It depends on your objective. What do you want to happen to your null hypothesis? Are you willing to accept them when in fact they should be rejected? Or are you willing to reject them when in fact they should be accepted? Okay. So if you are caught between two dangers, I suggest you go in the middle and then use 95 to be a little bit balanced. But then again, this should not be a rule. Okay? Still, it depends on your objective. Okay. Are we clear on that? Any
Yes,
more
po.
question? Okay. So that leads us to the end of our hypothetical testing. Now you will be able to draw a conclusion. So this is the end of the story. Are you still with me? Hello.
Yes, sir.
Yes.
End na ng ating story. So wala nang season 1, wala nang season 2, ha? So tapos na tayo sa kwentuhan. Okay. So most probably the next question is, how are you going to use your statistical test? So for the benefit of time, are you still willing to commit another 20 minutes for that? I will just give you example so that you will learn on how to apply these decision rules.
Yes, sir.
Okay, let's proceed. Z-test. Okay, so what is a Z-test? Z-test again comes in three forms. We have the one sample, the paired, and the unpaired. The following criteria must be met if you want to use your Z-test. Number one, it should be normally distributed. You are only comparing two means. You know the population variance or the standard deviation, and most of all, more than 30 samples. Do you agree?
Yes, sir.
Okay, I'll give you an example. As a sleep researcher, you are curious about how sleep habits change during COVID-19 lockdown. So you collected your sleep durations, okay, in terms of your data, during and before the lockdown. So your question is there a relationship between the sleeping habits during the pre-COVID and the post-COVID? Or ano ba to? Pre-lockdown and the COVID time itself. Okay. Understand the scenario. Before the lockdown, the population mean was 6.5 hours. So you're given with the value of your population mean. The lockdown sample mean is 7.62. So you don't need to compute for this anymore. Population standard deviation is 0.05. So this is your scenario. Internalize the scenario. Are you ready to test?
Yes, sir.
Let's start. So what's the first step in doing a hypothesis testing?
Organize
Collect
data.
You analyze your data.
Or
Okay. So first step, let's analyze the data. Your data is your population mean is 6.5 hours. Sample mean is 7.62 with the standard deviation of 0.05. So at this point in time, what do we know? What do we know? Information about your population, your sample, and your standard deviation. So let's assume that your data is normally distributed. Okay. And you are using time as your measurement. Time is considered what type of data?
Interval.
Interval. Okay. Are you still with me?
Yes po.
let's proceed to the next step. What is the next step?
State the hypothesis.
State the hypothesis. So how would you state the hypothesis? Remember, we're comparing sleeping hours before and during lockdown. Is there an effect? Compare. So how would you state your null hypothesis?
There's no significant difference.
No, there is no difference. Parehas lang. Kung matulog, pre, and during lockdown. So this will be your null hypothesis. Equal. Sample mean has no difference with the population mean. Meaning to say, the pre and the post results are not different. Okay, what will be your alternate hypothesis?
Is a significant difference.
Yes, there is a difference, no, between pre-lockdown. Nung pre-lockdown, mas masarap ang tulog ko, pero nung nag-lockdown, masyado na akong anxious or whatever. Kaya mas matagal, mas mahirap ako matulog or mas maiksi ako matulog or the other way around. So, you are going to disagree that there is similarity. So, you use this one. Okay. Are you willing to point to a certain direction? Which one is higher or which one is lower?
No.
Okay. Since you use this sign, you did not use either you want which one is lower or which one is higher. So you are looking at what type of tail?
Okay.
Two tail. Remember that. Now, next step. What is the next step?
Establish
Ikaw.
confidence.
Establish your
Confidence level.
confidence level. So at this point, we will select 95% as your confidence level. Diba sinabi natin, if you know the confidence level, most probably you can get the equivalent p-value. What is the p-value of a confidence level of 95?
0.
5.0.
5%.
Or an alpha level of
0.
0.05. Okay. So how does it look when you paint it? Okay, meaning to say, your confidence level is this one to that one. Correct?
Yes, sir.
Okay. Equivalent to 95%. What is the p-value of your test or the established margin of error? Or the p-value of your population? Which one? This one. 0.05. Okay. So, if this is your confidence level, what about this one? What do you call this one?
Significance level.
Significance level. Or your
Alpha.
Alpha. P-value.
or your alpha.
Alpha.
Halos magkakaparehas lang yan. Okay. In terms of using a critical or calculated value, your 0.05 from the population has equivalent critical value of 1.96. So, dito, your z-score will be 1.96. Positive, negative 1.96. Okay. Sir, saan mo kinuha yung 1.96? Saan natin kinuha yung 1.96 as your critical value?
Table.
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 Okay. So, assuming that your 95 will give you a confidence level of 95, will give you an equivalent z-score of 1.96. Yeah. Okay. So it is also an empirical value. You assume that if you have a p level of 0.05, the z-score equivalence is 1.96. Now, we have set parameters for we prepared your parameters for decision making. Okay, you have established the margins of decisions, you establish the level of your confidence level, you establish the level of your significance, you establish the p-value of your population. What is lacking now? You even establish the critical value of your population. What's lacking now?
Calculated.
Calculated value. Sample p value.
The value of your test. So let's find out also the p-value or the calculated value of your t-test, of your sample. Okay, so let's proceed. What did we know? We have the confidence level of 95, an equivalent z-score of 1.96, and a p-value of 0.05. All came from this table. Okay, so what did we know? A data that is normally distributed, quantitative, more than 30 sample, with a known standard deviation. We are comparing two samples, meaning the sample of the mean and the sample of the population. We know what we want. We want to compare the two mean of the pre and the post. Okay. And the direction, what did we say, Kanina? It's 210. Okay, because we are not after which one is longer, which one is higher. We are, because we did not indicate it, whether less or high. We use this one. So we are just after the comparison, the differences, not the exact values. Which one is bigger, which one is smaller, which one is longer, which one is shorter. So this will lead you to what choice of statistics?
One sample z-test.
Okay, one sample, meaning to say you're comparing your sample towards the population, which is the pre and the post. During lockdown. So this is one sample. How many tests? How many data set?
30.
You know the standard deviation, right? So this will give you decision to use
Z-test.
z-test. Okay, so how do we do or perform a z-test? The formula of your z-test, again, I'm not asking you to memorize formulas. Just for the sake of discussion, I need to show you the formula of a z-score, z-test. The formula of your z-test is sample mean minus the population mean divided by the standard deviation. Okay. What is your objective here? You want to calculate for the value of
Sample p-value.
sample calculated value and eventually as a p-value. Okay. So let's do the math. 7.62 is your sample mean minus 6.5, which is your population mean, divided by your standard deviation of 0.05. This will give you the amount of 2.24. So this is your z-score, which can be now your calculated value. Okay. So the calculated value of your sample is 2.24. Do you agree?
Yes.
Okay. How do you determine or how do you compute for the p-value?
Use the Z table.
The table, very simple. So you go to 2.24 2.24. 2.24. Yes. So the value is, what's the value of 2.24?
0.48.
0.75. Right? Okay. So meaning to say, this area is 48.75%. Can you derive the value of this, the confidence level of this? Can you now determine the confidence level equivalent to a z-score of 2.24? This one.
Times
2.24.
98.75.
Okay. So what will you do? You assume
Times
the half of the curve is 50%, right? So 50% plus 48.75% equals to,
98.75.
sorry, equals to 98.75. So 1 minus alpha means 100 minus 98.75. Tama?
Yes po.
Okay. The result is
1.25.
1.25%. Okay, so this one. And when you this will now be your value of this. Get the point? This is your critical value, which is 2.24, close to 2 standard deviation. So invest na 90 ito, and invest na 95 ito. Anong value niya? 98.75, right? So this is your confidence level. Kung i-compare mo, and what remains here will be
Significance level.
significance level, which is equivalent to your p-value of what? P-value of 1.25 or 0.125. Of what? Kanino to?
sample.
Sample. Okay. So what we know now is you have to plot it in the curve. With the given, what did we know? We know the confidence level, right? Of the population. Tama?
Yes po.
Which is 95. Okay. Which is equivalent to 0.05. And this will be your margin. Okay. Are you still with me?
Yes, sir.
Yes.
0.05, if you convert it into a critical value, becomes 1.96. Right? You still remember?
Yes
Yes,
po.
sir.
No. Z table.
Yeah. See table, 95 is equivalent to 1.96. So therefore, your margins of error will be dictated by the value of your population P or your critical value, which is 1.96. Do you agree?
Yes, Doc.
Yes.
Okay. Now, we computed for your sample. What was the calculated value of your sample? You still remember the calculated value?
2.24.
2.24. Okay. And the equivalent p-value, you still remember?
0.0126.
0.126. Okay. Now, decision will come easy. So how would you decide? Let's use the p-value first. Okay. Decide basing on the p-value. So what is your p-value? Your p-value of the test is,
0.0126
so will it be located outside or within the margin?
side.
Outside. So nandito siya. Okay. So what will now be your decision based on your p-value?
Reject null hypothesis.
Your p-value is less than 0.5. Do you agree that 0.1, no, 0 dapat yan. 0.0126. 1 times 100.
Value, sir, is
0.0126. Which is greater? Your population or your sample?
Population.
Population. So therefore, what will be your decision?
Reject.
You reject
Reject.
the null hypothesis. Ano na nga ba yung sinasabi ni null hypothesis kanina?
There is no real
No
No
significant.
significant.
Okay. So sabi kanina ni null hypothesis, no, there's no significant relationship. Now, you want to reject that. So therefore, your conclusion will be to accept your alternate, which alternate says
There is.
there is a difference between pre and the post. Are we clear?
yes, sir.
Very good. Let's
Sir,
use
may tanong.
yes.
Yung sa previous slide, sir, how did you come up with the 0.04, di ba? Itong previous slide, yung sa table,
Point
yung
zero.
sa,
Which one is 0.04? Did I
yung,
mention 0.04?
yung previous slide, sir.
The value of calculated
Yan. Yan sa taas, sir, yung, di ba, na 2.2, yung binilikan nyo po, tapos
Ito?
yung vertical 0.4. Yung,
I don't get it, Doc Romel.
ito yung 2.4, sir, yung sa table po. Di ba, yung sa right side, 2.2. Tapos yung binilugan nyo yung 0.4875.
Oo.
Tapos yung taas na 0.04.
Oh,
Kita.
2.2
Z
plus
score daw.
0.04, that will be
Yeah, that's right, sir.
2.24. And the intercept of 2.2 plus 0.4 will be 0.4875,
2.24.
which is equivalent to 2.2 plus 0.04 on your
Oh, there you go. Sige. So i-add mo po sa ano yung 0.04 sa 2.2, parang ganun.
kasi 2.2
Yes po.
lang yung value mo dito sa z-score eh. And you have 0.4. So you still have to add 0.04.
0.04.
So you get that
Okay.
from the other column. So 2.2 plus 0.04 there, and then the intercept will be your 48.75.
Okay, got it, sir. Thank you.
Did we answer it right, Dr. Romel?
Oh, sir.
Okay.
Okay, thank you, sir.
So let's proceed. Saan na tayo? Now, let's use the critical value and the calculated value as your decision rule. Okay. So what is your calculated value?
2.24.
Yeah. Sorry. Your calculated value is 2.24. Your critical value is
1.96.
1.96. So assuming this is 1, 2, 3, 4, 5, 6. Where is your calculated value located?
Outside.
Outside. So you are going that way, right? So you are located outside. So it is very easy to make a decision. So what will be your decision? If your critical value is less than the calculated value or no? Let's put it the other way around kasi nandun tayo sa positive term. If your calculated value is more than your critical value, then you have to
Reject null.
Reject
Mm.
your null hypothesis kasi nandito siya ng outside decision box. What I want to point out is the values of P and the values of the calculated value. Okay. Again, napansin nyo ba na ang p-value, the more it gets smaller and smaller, the further you get away from the margin, right? So 0.05, 0.01, 0.001, 0.0001. So habang palit ng palit yung p-values mo, palayo ka din ng palayo sa margin. Ibig sabihin, padami ng padami yung evidence mo to reject your null hypothesis. But take a look at your critical value. 2, 3, 4, 5, 6. So imbes na pababa ng pababa katulad ni p-value, pataas ka naman ng pataas. Right? 2, 3, 4, 5. So what I'm trying to point out is don't be mistaken with p-values and critical values. P-values, as it goes slower and slower, the more you're going to reject your null hypothesis. With your critical value, the bigger it gets, the more you're going to what? Reject your null. So huwag kayong ma-confuse. Again, habang palit ng palit yung p-value mo, the more reasons for you to
Reject.
what? Reject. In terms of your critical value, habang pataas ng pataas, the more reason for you to
Reject null.
reject. Okay. So it looks like they are
Inversely
opposite. Okay. Not inversely proportional because they don't have same values. So the decision making is quite like, the opposite of. So don't be mistaken when you make decisions, whether you're using calculated critical value as your decision tool or you're using the p-values. Okay, because they have different decision rule or basis. Okay. Are we clear on that? Are we clear on that?
Yes, Doc.
Okay. So we have successfully arrived to a conclusion. Okay. Do you want another sample? Can you still bear with me for siguro mga
Yes po.
10
Yes, sir.
minutes? Anyway, wala pa naman tayo dun sa Okay. Another scenario. An alcohol dispenser dispenses 80 ml of alcohol. CSR personnel who bottles the alcohol does not believe that the dispenser dispenses an average of 80 ml. So he tested 40 samples and averaged the amount of average the amount dispensed by this sample, okay, which is 78 ml. He computed for the standard deviation and it came up 2.5. Okay. So how are we going to do your hypothesis testing? Let's start. First step. First step. Organize. Okay, so we organize your data. So let's assume that this is a normally distributed curve. Okay, given na yan. We know the number of samples. This is 40. Okay, we know the standard deviation. Okay, at this point, what do you have in mind? What type of statistical test you can use with this type of situation?
Z-test.
Yes.
Z test. Okay. So let's make a decision. Second step is you state your
Hypothesis.
Hypothesis.
hypothesis. Your null means no difference,
Different.
and the alternate means yes, there is.
Significant.
Okay. So what you're going to do is the same. Next step is you give your
Confidence level.
confidence level. So it is a given. Let's say it's 95. So for a 95% confidence level, what is the expected p-value?
0.05.
0.05. Again, go to the transmutation table. 95 has an equivalent z-score of
1.96.
1.96. So you can keep on repeating this one. 95 is equivalent to 1.96 if I am using the z table. Let's plot. 1.96 is here. This will be a critical value. If it happens to be pointing towards the lesser portion, you have a negative 1.96 and positive 1.96. Again, the margin of rejection is equivalent to a critical value of
1.96.
and still at the level of 0.05. Okay, so what's next? Let's calculate for the value of your sample.
Hmm.
So far, what did we know? You know the sample mean, you know the population mean, you know the standard deviation, and you know the number of samples. So let's use the formula of C-test. Mean minus the mean of sample minus population mean, and so on and so forth. So we came up to your value of Z. Negative 5.06. Okay. So since we are not looking only to the positive side, we try to look at the other side because this is where your data, your result lies. It lies on the negative side. So we also have to calibrate accordingly. So if this is your critical value, okay, for positive, this is the critical value for negative. And your calculated value is negative 5.06. Where does your sample test calculated value lies?
Outside
Outside of
critical
the
margin.
margin. So what are you going to do now?
Reject.
Reject. Okay. You now reject your hypothesis, null hypothesis, which means that there is no difference. In fact, there is a difference. Okay. So we agree with the alternative. So, ganun lang kadali mag-decide. Okay? So, in terms of p-value, we will calculate the p-value of 0.0026. Okay. The established p-value is of your population is what?
0.05.
Population value is 0.25. The p-value of your sample is what? Kinumpute na natin. The p-value is 0.0026. Do you agree with me?
Yes, sir.
Okay. The equivalent p-value of your Z calculated value is 0.0026. Kinumpute ko na yan. Okay. What all you have to do is to decide. So I will give you the sample p-value. The sample p-value is 0.0026. The p-value that you are using, since you are on the one side, you divide the 0.05 that is previous, so you have 0.025. Still, you compare. Which one is higher? Your sample or your population? Uy,
Population.
Okay. Population. Isa lang yung zero niya, di ba? Ito dalawa. So mas maliit ito. So still, you are going smaller and
Reject.
smaller and smaller and smaller. Your p-value. Okay? So, you're going to still compatible of what you did when you use the critical value and the calculated value, you're still going to reject your null hypothesis. Is that clear?
Yes, sir.
Okay, very good. So, your conclusion is, you can conclude that 95% as your level of confidence, you cannot accept your null. So therefore, you're going to reject it, right? And settle for your alternate hypothesis, which means that the average amount of alcohol dispensed is not equal to 80 ml. Okay, so you have a decision. Do you agree with me?
Yes, Doc.
Do you
Yes,
know
sir.
now how to apply your p-values and calculated p-values?
Yes, sir.
All of the statistical tests aims of creating your calculated value and your p-value of your sample. Pare-parehas na yan. Iba-iba na lang yung formula na gagamitin. At the end, you will be provided with the value of your sample calculation and the p-value of your sample. Wherein you're going to use this as your basis for decision making. Okay? Are we clear on that?
Yes, sir.
Okay. Would you like to have an example of t-test, how it is being used?
Yes, sir.
Okay. Your t-test. I'll give, again, your t-test is just the same as your z-test. Except of the number of samples. So your t-test is for less than 30 samples. Your t-test has a t-score. Your z-test has z-score as well. The good thing with your z-score is the value of your z-score is almost similar to your standard deviation. So that a z-score of 1 is equivalent to 1 standard deviation, a z-score of 2 is equivalent to 2 standard deviation. In the case of t-test, wherein you are going to take your t-score is not the same as your standard deviation. You are still going to test the value of your t-score using a formula, wherein you should be particular with the degrees of freedom. The degrees of freedom means the number of score or number of sample minus 1. So that will be the equivalent of t-score. We did not do this with your z-score. We went directly, okay, to converting your 1 standard deviation as your standard, as your z-score. But in t-test, you have to convert your t-score accordingly. Okay, you use this formula. Okay. So again, this is applicable to the different type. Okay, I will give you a scenario. A company manufacturer of a portable OR lamp claims that their product has an average lifespan of 2 or more years. Your bioengineers believes otherwise, that the average lifespan is less. So they tested 10 OR lights and they measured the average lifespan of those 10 OR lights. And they found out that the average lifespan of those 10 OR lights is 1.8 years. Now, they want to compare if what the manufacturer is saying that is 2 or more years is compatible of what they found out, which is only 1.8 years. So does this make any difference? Okay, can we accept the claim of the manufacturer that yung product niya 2 or more years when in fact 1.8 years lang pala? So you have the power to reject or to accept the OR lamp that they are delivering to you. Ay, ayoko sa iyo. Niloloko mo ako eh. Nagsisinungaling ka. Sinasabi mo 2 or more years yung warranty ng mga OR lights mo, eh, hindi naman pala, mas mababa pa dyan. So we want to test. We have to compare if we can accept the claim of the producer that is just 2 years. And if you compare it with 1.8 years that you found out, that it does not make any significant difference. There's no fuss about it. So we can forgive the producer. So we will continue with the deal. We still have to buy OR lamps with you. Okay, so you are tasked to test the difference. So alam nila you are already a master's degree in hospital administration and MBA. So tinawag ka. Tulungan mo naman ako, sabi ng director niyo. What will be the decision? Okay. So, ikaw, anong gagawin mo? First step, you have to test that
Organize the
hypothesis.
data.
Okay, give us the data. Okay, let's just assume again that this is a normally distributed data. Next. Next,
Hypothesis po. Statement.
hypothesis. This time, in-establish mong hypothesis is you use tank and that one. Okay. Meaning to say, you are seeking
Direction.
direction. So most probably, you are going to use what type of alternate hypothesis?
One-tailed.
One tail. Okay, it's either here or possible here. One tail. One tail using 10, which is less than 30. Probable test statistics that you're going to use is
T-test.
T-test.
t-test using one-tailed t-test. Okay, let's proceed. So determine if the test two-tailed or one-tailed. You said one-tailed. So in this case, we will use then the one-tailed test. Specifically, the left tail, because you're pointing to which one is longer. Lifespan. Okay. Next. After your hypothesis, anong sabi natin? What's the next thing that you have to do?
Confidence.
Confidence level.
You make your confidence level. So at this time, instead of using 95, let's try other confidence level. So we decided we use a 99% confidence level. Okay, do you agree? Do you agree that we can use other confidence level?
Yes
Yes.
po.
Yes. So assuming that we choose 99% of your confidence level. So we have to transform the T score and eventually the critical values and its equivalent T value. Okay. So you have the table and this is your table. Mali ito. Dapat this is a T table. This came from T table. So at a level of 99, okay, you use 99% of your confidence level. Expectedly, your T score is equivalent to
2.58.
0.58. So what does this mean? Okay. This will serve as your
Critical
margin.
margin.
Critical.
Serve as your margin. So invest kanina kung this is 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, and so on and so forth. So usually na ginagamit natin is this one, right? To standard deviation, which is 95. But this time we decided to increase our beta level, to increase your confidence level to 99. So somewhere near 3 standard deviation. Kasi yung ng 3 standard deviation is 99.7 eh. So most probably your 0.99 will be a little bit close to 3. A little bit close to 3 there. And this is equivalent to 99%, right? Correct?
Yes
Yes,
po.
So what is the equivalent critical value of your 99?
2.58.
2.58. Now, we will solve for the value of your sample. Okay. What we know, we have the number of tests, which is 10. This is less than 30. We have the mean, we have the sample mean, we have the population mean, we have the standard deviation. So your choice of statistic is T test. Okay. So sabi natin kanina, in order to arrive at your T-score, you just have to use the formula of degrees of freedom kasi yung table mo uses degrees of freedom instead of a Z-score. So degrees of freedom. How would you identify the degrees of freedom? That will be the number of sample, which is 10 minus 1. That will be equivalent of a degrees of freedom of 9. So go for the degrees of freedom. That's 9. That's 9. Okay? And are you using one tail, two tail?
One tail.
Of what t-value?
0.01.
Okay, so you use this one tail going to 0.01. So let's see the intercept. There. There. Okay. So you arrive at t-score of 2.821. Correct. Do you agree with me? And
Yes.
this will now be your critical value or the t-score. Okay. If we use the z-score, it would have been different. The value of your critical value would have been different. But since we computed for the critical value using your t-table, okay, with emphasis with the degrees of freedom, okay, let's assume that we arrive to a critical value of 2.821. Okay, so where will this lie? Usually, we use this one, the standard deviation of 95. Now, we are using this one, which is 99%. So the equivalent critical value of 0.99 is 2.821. Okay. Are you still with me? Which is equivalent to 0.01 as your p-value. Okay, next. Calculate for the value of
Hindi yun ang 2.821, sir. Yun na yung calculated value
no,
natin.
that is your critical value. We have not established our critical value for that. We have established for the value of 99 kanina, but I just show you how to use your computation table. So what we are looking at is the critical value. This will be your critical value. Okay? So what do we lack? What we don't have yet is the calculated value of your test. Okay, let's calculate the value of your sample. Okay, assuming the calculated value is negative 4.22. Okay, this is two-tailed. Your critical value is positive, negative 2.821. Okay. Saan mo ilalagay si 4.22? Negative 4.22.
Sa
Let's
left.
take a look at the left tail. Okay? Since this is negative 4.22, where do you expect to lie? Your sample. Where do you expect
Outside.
your sample to lie?
Outside
Is
of the
outside
critical.
your rejection region. Okay? Your rejection margin is negative 2.821. Your calculated value is negative 4. So it is way, 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 way away from your critical value. So it lies on the rejection region. Now, can you make a conclusion?
Reject the null hypothesis and accept the
Reject.
alternate.
The null and accept the alternate hypothesis. Okay? We use this decision rule. Any question? Again, don't be too specific. Pwedeng nagkamali tayo doon sa calculation, no? But again, that's not what we're after for, no? We are after your capacity to decide based on the provided data. Okay. Were you able to decide using the values that were presented to you? You were, right?
Yes, Doc.
Yes, sir.
So we met our objective of making a sound decision or conclusion. Okay. So for a paired test, sabi natin paired test is before and after, right? So this scenario naman, okay, you will test if using or upgrading your software will give benefit to your institution. Like for example, your applications dati, these are the speed of the test, okay, and then you upgraded it. For example, you were using the iFomis or DOH or the BizBox. No? Let's just say the BizBox. The BizBox, you are using the older version of your BizBox. You want to know if it is practical to upgrade it, because when you upgrade, it also entails financial requirements that is very high, very expensive. Now, do we need to upgrade or not? So let's test before and after the upgrade. So you're using what type of test? Sample within sample. Same, before and after. You use the paired t-test. Do you agree with me? Kanina, we used the one sample t-test. Ngayon, we use the paired t-test because we are treating one sample before and after. Okay, internalize. Understand the scenario. This is the speed of BizBox before and after it was being upgraded. Okay, so let's see if there is a difference. If it is practical for you to upgrade with that large amount of money that you will shell out, is it practical for you to upgrade? Based on the different results you have in here, let's test. Let's compare the difference before and after. Okay, so you know the data. First step again is, what's the first step?
The data.
Nice.
Organize. Okay. Next step, proceed with
Hypothesis.
your hypothesis. So it still depends. Kung ang objective mo is just simply to differentiate without, trying to know which one is better. Okay, gusto mo lang malaman kung there's a difference. That's why you use equal sign. Okay? And did not equal sign. So you did not use which one is lesser or which one is higher. So, what type of test will you use? One tail or two tail? Two tail. So, since you are just after the differences, you are not after the direction, you use the two-tail test. So in this case, or in this scenario, we use the two-tailed t-test. Okay, next. After hypothesis, what's next? What's next with the hypothesis? Third step.
Level.
Confidence level. Okay, at this time, let's set your confidence level at 95, which is equivalent to an alpha level of 0.05. Okay, let's calculate for the critical value. Critical value is degrees of freedom. N minus 1 equals 9. Again, you go to your table and you calculate for the degrees of freedom. 9. Degrees of freedom is 9. Using two-tail, 9 at level of confidence of 0.05, right? Degrees of freedom of 9. The intercept
Yes.
is 2.62. Okay. So this will be your critical value. This will serve as your margin. Next, your sample, right? So we have to find the value of the calculated value of your sample. Let's do it. Blah, blah, blah. Okay. The test is very busy, very intimidating. So I will give you the result. The calculated value is 3.61, positive 3.61. So what happens? Let's plot. What was your critical value?
Point
2.262, right? What is the calculated value?
3.6.
3.61. So where does your 3.61 lies in terms of the curve? Inside or
outside.
outside?
Outside.
Inside or outside?
Outside.
Outside.
Well, we're using the critical value, huh? So it is located
Outside.
outside. So therefore, what happens?
Reject.
What happens?
Reject.
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 You agree?
Yes, sir.
Okay. You can compute also for the p-value if you want to use the p-value as your decision rule. So there will be equivalent p-value. What is the equivalent p-value still? You use your 0.05, right? And kinompute ba niya yung p-value ng test? I think hindi na. Hindi na niya kasi kinompute your p-value of test. So, nag-depend na lang siya sa calculated value and critical value to decide. But anyway, there was a decision made that was based on statistics. So, most probably, this is a sound decision. Okay? Do you agree?
Yes,
Do you
Doc.
agree? Okay. So are you getting more comfortable of using the critical or the p-value as your tool to decide whether to reject or accept the null hypothesis?
Yes po.
Yes. Okay. So you can do this also in your Excel. So we will explain how to use this by Excel during your reporting next meeting. Okay. ANOVA. ANOVA is 2 or more. Still, the objective is for you to calculate for the p-value of your test or your calculated value. Okay, and then use this as your decision. Okay, so you are comparing more group 1, group 2, group 3, blah blah blah. You identified your data, establish your hypothesis, you determine the level of significance. This time 90 naman ang ginamit. So 0.10 ang level of significance niya. Okay, you computed. This is how you compute. Long way. Very long way. Very long way. Okay, so we came up to the result. The calculated F value this time is 12. Okay? Are you still with me? And the computed critical value is 5.14. Okay, still. The critical value is 3.46. And the calculated value is 12. Where do you think your 12 lies
Outside.
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 So therefore, same thing. You still have to decide whether to reject or accept your null hypothesis. This time, we're going to reject or accept.
Reject.
Reject.
Reject. Okay. You made the decision. Our objective is that. Okay. Do you agree? Ganun lang pala kadali. If we disregard the computation. Diba? You just need your p-values and your critical values to make a decision. Okay. Again, you can compute. Instead of doing the long method, it will give you 3 pages of your yellow paper just to compute for your ANOVA. But if you use your your Excel as your calculator, okay, it will just need few clicks and you will arrive at the value of your P and you will arrive at the value of your T. This will be explained by the reporter. This is how you're going to report. Okay, so I gave you a scenario for your Z-test, for your T-test. So what you have to do is analyze it using the steps. First, nandun naman ang assumption. If normally distributed, you make your null hypothesis, you establish your critical value or the p-value of your sample, then you calculate for the value of your sample using Excel, and then show us on how you arrive at your decision. So ganun kayo mag-report. Ganun lang kadali. So this one is example on how you're going to use your ANOVA using your Excel. But there's no need. Again, next is your chi-square test. Chi-square test is a non-parametric, usually for ordinal and rank. Okay, ordinal or nominal, and it seeks to establish a relationship of expected versus the actual or the observed. Okay, again, the formula will result to the sample p-value and the calculated value. For example, yeah, mga absences, i-compare mo. We're running out of time kasi. So these are your observed and these are your expected. Now you have to determine if they are related. Okay, if your observation fits the expected or the expected fits the observed. Okay. Again, the steps should be followed. Identify your types of data. Okay, not necessarily for the distribution. Kasi distribution for chi-square test, it does not worry about whether it is normal or abnormal. Okay, then you have to state your hypothesis. Okay, hypothesis will be equal or unequal yung frequencies nila. Again, you have to find out the critical value. Okay. Critical value. So since we are dealing with a abnormal data, gumamit tayo ng skewed data just to exemplify an abnormally distributed data. So we are dealing with an abnormally distributed data. That's why it looks like this. It does not look like this anymore. But still, it has its own parts. You can still delineate the decalibration. 0, 1 standard deviation, 2 standard deviation, 3 standard deviation. Okay, you calculated for the critical value. Critical value is degrees of freedom. This is equivalent to n minus 1. So you arrive at a critical value. And your established level of significance is 0.05. So let's test for the value of your sample. Ito, example lang yan. Degrees of freedom is 5 minus 1. That would be 4. the intercept with the given levels of significance of 0.05, so 9.49. Okay, that's where your 9.49 came from. So your 9.49 is your critical value, right? So what you need to know now is your sample calculated value. Okay, so let's just assume this is the formula of a chi-square test, blah, 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 computed, and the calculated value is 6.3. Let's compare. What's your critical value?
9.49.
9.49. What is your calculated value?
6.3.
6.3. Nasaan si 6.3?
Inside.
Is it outside or inside?
Inside.
Again, pag ganon yung degree ha, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6.3 is less than your 9.49. So therefore, it falls within the
Within.
acceptance region, right? Or the do not reject region. So meaning to say this is the acceptance region. Therefore, your
Accept null.
conclusion is
Except
reject or accept?
Accept.
Accept.
Accept. Okay? Kasi nandito ka within the acceptance region. You are not outside. So you don't fall in here, rejection region. Instead, nandito ka. So therefore, we're going to accept you're not. Okay? So what did we learn? Still, chi-square will give you the value of your critical calculated value and even the p-values, and then you will use that to decide. And it is very simple to decide once you know the decision rule. Okay. This is how you will compute in terms of your Excel. So I will not show you this one anymore para naman may gagawin at may explain si reporter. Next is your Pearson test. Your Pearson test, okay, ganun pa rin. This time, we did not use the Excel. We used the Minitab. Okay? Minitab naman. This is a very powerful tool also, which is mas kompleto ang Minitab. Napakamahal kasi itong applications na to. Kaya hindi mo siya makikita anywhere else. You can see that, you can borrow this one in your university, or kung may mga research center kayo, usually we use Minitab. Okay? See, in the academy, we use Minitab. In research work, we use the Minitab. So assuming that you use your Minitab, again, you input your data. Okay? So you want to seek relationship if A is related to B. Blah, blah, blah. You input it. So this will be the steps. Click on the data analysis. Okay. Check on the data analysis tool. You check on the correlation. Press OK. And then the input range, columns, your worksheet, etc., etc. And your Minitab will give you the value of your row. R. Okay. So this time, what is the value of your R? 0.84. You get the point? What is the reference value? This is 0. This is +1. This is -1. Nasaan yung 0.84 mo? To your right or to your left?
Right.
To the right. Okay. Which shows
Positive
that these two values, yes, very good, are positively related. Okay. But once you try to look at the distribution, hindi siya very sharp. Medyo pa ganun siya. So, it is still positively related, but to an extent, it is moderately related. Because when your 0.84 comes closer to +1, the more stronger the relationship towards positivity. So as you get close to positive 1, mas magiging strongly related sila. So since medyo lumayo siya sa 1, pababa siya ng konti. So we can say it's a moderately related values. Okay? This time, your mini-tab produce the value of your correlation, which is in terms of R. Okay? And use this R to make a decision. So this is your correlation test. Okay? Let's use the linear regression or the regression test. Again, in this case, we are establishing relationship but with the degree. So instead of using Excel, we use the Minitab. Okay. It seems to be a little bit more complicated, but the process is still the same. Garbage in, garbage out. You have to use equations. You have to use formulas that you have to choose. Okay. So your decision of choosing which one is the best or appropriate will depend on you. Okay. So like for example, we treated your data, blah, 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 blah. Okay. Your Minitab gave you the value of your T's. Okay. So you can use this as comparison. And it even gives you the significance level, the p-value, and so much more. Okay. The decision rule still remains. The significance f value or your p-value will still be if it is more than 0.05. Okay. Meaning to say you have to decide in favor of your null hypothesis. If it is less, then you decide against your null hypothesis. So yeah, kukumputan ka niya. So I don't think we can discuss this one by one. Okay? So at the end, you still have to generate the p-value and use this p-value to make decision. Same. Pare-parehas lang naman yan sa statistics. What we are after is p-value, calculated value, or in terms of your correlation, the value of R or your rho. Okay? Yung rho, medyo slightly different lang yung decision making mo. The closer it gets to +1, the stronger the relationship. The further it gets to -1, or the closer it gets to -1, the stronger the opposite. Okay? Yung relationship nila. Mas malayo yung relationship nila. So if you go to 0, it means there is no relationship at all. So ito yung gagamitin mong decision rule. Okay? Instead of, plotting it in his like this, you use the raw, the value of your coefficient of regression. Whether +1, 0, or negative. Okay? So that ends everything, I guess. The only thing now is how are you going to present your data when you write it down? Okay? So there are tips then and techniques. You just have to read this one. If you are going to report your result, okay, you are going to mention all the descriptive result. Okay? So for example, your conclusion is consistent with the alternative hypothesis. The experimental group has a mean of standard deviation of 2.14. Okay, reportedly significantly more happiness than control group. You mentioned the mean also of the other group, the standard deviation of the group. You mentioned the t-value, the p-value of the sample. Yeah. Okay, this is how you will write down your result. Okay, when you want to report your p-values, okay, again, you still need to mention the mean, the standard deviation of your one variable, the mean and standard deviation of the other variable. Okay, you mention the number of samples and the p-value of your sample. So this is how you will write down your conclusion or your decision. Huh? So there are just some techniques that it is better read than explained verbally. No, you just have to read this one because this is more on technical writing. This is how you're going to present your result. Okay, when you're reporting test statistics, okay, example is ganito. Your conclusion will look like this. By surveying random subsets of 100 trees over 25 years, we found statistically significant with a given p-value 0.01, and it has a positive relationship with the temperature flowing flowers given with the correlation result of 0.36, positive 0.36, and standard deviation of 0.057. Meaning to say, those that you generate, the values that you generate in your descriptive statistics, as well as your inferential statistics, you have to mention them all in your conclusion so that you will produce a well-rounded picture, more dimensional picture in order to understand more about the information of your data. Okay? Do you have any questions? Before we end, I think we reached the end of our course. We were able to achieve our objective of how you're going to test your hypothesis. Okay, very important is to memorize the steps and your ability to determine the type of data, the relationship, and the samples that you have for more appropriate statistical test that you're going to use for every data that you have. Okay? So again, we have different statistical packages. We have your Excel, your Minitab. You can use also those ones from Windows, your Apple. So each and every one has their own pros and cons. No? So your Excel, pros is it is easily available. Madali lang siyang i-operate. The cons is some statistical analysis are not available. So your Minitab, okay, most of the statistical process is there, but in terms of cost, this is very expensive, so it is not readily available. And it is harder to do than your Excel. So it has, you have all the options of using these different applications, no? Instead of using the long method, okay? You all have the choices. So I presented it in a table. You can just read it. Which one do you prefer? But when you're level, I think you can settle with Excel. The best part is you use the Excel. The Excel has the basic functions that you need in your statistical analysis. If you want to go further in usually mga experimental type of research, huh? Okay, Minitab is the best application that you can use. But for managers, okay, just to use it in decision making, I guess, sorry, Excel will do the work. Okay. So, thank you. This ends our discussion. For next meeting, we will tackle more examples. So your reporter will report on Z-test, T-test examples, and they will show us how to arrive at a decision. Okay, maybe you can show us how you use your Excel in order to arrive at the value of your P, your critical value, no? And then teach us on how you made your decision. Okay, and let's see if we agree with each other. So that will be for the last session. That will be our last session. Okay. So all the lectures are delivered. This will end our lectures now. So for the next meeting, we'll all be reporting, and if possible, will you be able to attend to your final exam next meeting? I will give your final exam. Can you still add additional burden your exam?
Ilang oras po yung exam?
Now you can do it at you can do it again for 24 hours. It will be a multiple choice. There will be no computation. So just the application of principle. 100 item, multiple choice. So I will open it on Sunday evening, 7 p.m. good for 24 hours, you're expected to pass that final examination the day after. Okay? For your assignments, your descriptive stat is done or hindi pa? Yun yung next natin ng December 3, di ba? Yung descriptive stat ninyo. Right?
Di pa, Doc.
Okay. Yung inferential stat, kailan yung gusto yung deadline?
Third week ng December, sir.
Okay. 1 week after our last session. But
Yes, sir.
promise me that you have to pass it because we are only given 1 week after the last delivery of subject. Okay, we are supposed to give you your assessment. Kayo din, hahanapin nyo sa akin, wala akong maibibigay. So, can you promise me that you have to pass all requirements 1 week after our last session? Will that be fair?
Yes,
Yes,
Fair,
sir.
Doc. Yes, sir.
So,
When is the last session, Doc?
next Sunday, December 3, I think all surgeons will be attending the Philippine College of Surgeons Convention, annual convention.
Yes, sir.
Doc Johan, kita-kita tayo sa PCS. But I think this will be the evening of the Sunday. So I assume you will be at home. Will this be fair if you will not attend the fellowship night? For one. Sabi ko sa inyo you will sacrifice a lot. You will sacrifice a lot. Yung wife ko magpapaanak. My wife
Ano,
is
sir?
a statistician.
December 3 yung last session po. So, December
Okay.
10?
So let's make a calendar. December 3 is your last session. December 3 will be the due date of your descriptive stat assignment. Do you agree? And
Yes.
a week after that will be, what's the date? A week after December 3. December 10. A week after will be December 10. Okay? December 10 will be the due date of your inferential stat. The one that we're going to discuss on December 3. Is that clear?
Yes, sir.
Okay.
sir.
Your final exam will be open on December 3. Oh, it's unfair for you. Can we open your exam December 4, 7 a.m.?
Doc, why not December 10?
Ang exam ninyo?
O kasi hindi pa naman tapos.
Doc, December 10, Doc, ang exam. Tapos December 15 lahat ng assignments.
Pinahirapan niyo naman ako. Yung ano kasi, yung final exam nyo, automatic yan na chine-check ng system natin. While your assignment, I need to go through it one by one. So imagine, how many are you? I cannot finish the deadline for us. The deadline for us to submit your grades is 7 days after last session. So supposedly on December 10.
So 7 days after the last session. So
Yeah.
December 10 is the last session.
No, December 3 is the last session.
Yeah, but we'll be still discussing inferential statistics.
Yeah, that would be for December 3, right?
You said December 10.
December
No. Passing of your inferential stat assignment. Assignment. Descriptive stat assignment will be on December 3. Inferential stat assignment is on December 10. Okay? Your final
Di ba
exam will be on December 5, 7
Di ba pwede
a.m.
December 10?
I'm sorry? Doc
Di
Marks?
ba po pwede December 10
Ang alin?
ang exam? Total
Okay.
nag-auto-compute naman yun eh.
Yes. Grabe si Doc Morgs, oh. Nahirapan talaga ako. Sige na nga. Okay, no problem. So, would you like me to open the exam at December 4, but the due date will be December 10. So it will be open for 1 week. It's up to you when you want to access. Will that be
Okay,
fair?
nasa-
1
Sure,
week?
Better
Doc.
po.
Okay, ah.
Yes,
Okay,
sir. Okay
sir.
po.
Okay po yun, Doc.
Is